Uma história que começou em 1963, com décadas dedicadas ao desenvolvimento de processos, produtos e embalagens. O Instituto de Tecnologia de Alimentos não mede esforços para se manter como referência no setor alimentício, não só no Brasil, como no mundo. Por entender a importância da inovação e segurança de alimentos, bebidas e embalagens para o consumidor, o ITAL pesquisa e presta assessoria técnica, visando a eficácia e padrões mínimos de qualidade. Além de estar atento aos diferentes perfis de consumidor, o Instituto atua sempre com ética e respeito ao meio ambiente, priorizando a análise crítica para acompanhar a evolução tecnológica e de mercado. As atividades do ITAL são divididas em 3 grandes áreas. A tecnologia é desenvolvida e aplicada nas unidades especializadas em carnes, cereais, chocolates, balas, confeitos, produtos de panificação, laticínios, frutas, hortaliças e engenharias de processo. A ciência e a qualidade são prioridades dos laboratórios de análises químicas, físicas, sensoriais e microbiológicas. A embalagem é o foco dos setores especializados em materiais metálicos, vidros, plásticos, celulósicos e para distribuição e transporte. E o conhecimento vai além dos muros da instituição através de artigos, publicações e eventos. O ITAL valoriza as pessoas que são força de trabalho e razão de existência. Por isso, está presente em importantes programas de governo que abrangem todas as classes e diferentes gerações. São décadas de constante reinvenção, aprendendo e ensinando, décadas de reconhecimento com a bagagem do passado e a modernidade do presente. Com funcionários qualificados, uma história que começou em 1963, com décadas dedicadas ao desenvolvimento de processos, produtos e embalagens. O Instituto de Tecnologia de Alimentos não mede esforços para se manter como referência no setor alimentício, não só no Brasil, como no mundo. Por entender a importância da inovação e segurança de alimentos, bebidas e embalagens para o consumidor, o ITAL pesquisa e presta assessoria técnica, visando a eficácia e padrões mínimos de qualidade. Além de estar atento aos diferentes perfis de consumidor, o Instituto atua sempre com ética e respeito ao meio ambiente, priorizando a análise crítica para acompanhar a evolução tecnológica e de mercado. As atividades do ITAL são divididas em 3 grandes áreas. A tecnologia é desenvolvida e aplicada nas unidades especializadas em carnes, cereais, chocolates, balas, confeitos, produtos de panificação, laticínios, frutas, hortaliças e engenharias de processo. A ciência e a qualidade são prioridades dos laboratórios de análises químicas, físicas, sensoriais e microbiológicas. A embalagem é o foco dos setores especializados em materiais metálicos, vidros, plásticos, celulósicos e para distribuição e transporte. E o conhecimento vai além dos muros da instituição através de artigos, publicações e eventos. O ITAL valoriza as pessoas que são força de trabalho e razão de existência. Por isso, está presente em importantes programas de governo que abrangem todas as classes e diferentes gerações. São décadas de constante reinvenção, aprendendo e ensinando, décadas de reconhecimento com a bagagem do passado e a modernidade do presente. Com funcionários qualificados, clientes, parceiros e fundações de apoio, o ITAL tornou-se fundamental no setor de alimentos, bebidas e embalagens.
Each time there is a contamination in food or beverages, the public is made aware. What they don't see is you, mitigating risks every day, taking difficult decisions and making our food as safe as possible. because you take your job as seriously as we do. With over 350 years' experience in highly regulated industries, we understand the importance of reliability and efficiency in your lab. So be it to verify existing methods, stay on top of changing regulations, or to adopt the newest technologies. You can find it all on sigmaaldrich.com. Tailored products for each step of your workflow available on our website. We have products that are suitable for microbial and analytical needs in the crucial step of sample preparation. We have solutions for the most routine sample analysis to advanced genetic detection, such as the Assurance GDS for rapid pathogen detection, often used to test for E. coli in beef. And we support you with a complete set of services and specialists. Our experts are here to improve your day-to-day work with 4 dedicated portfolio brands: Millipore, Sapelco, Sigma Aldrich, and MilliQ. All these products can easily be ordered on our website so that you can focus on making sure that every sip, every bite is safe because it's been tested by you.
Uma história que começou em 1963. Com décadas dedicadas ao desenvolvimento de processos, produtos e embalagens, o Instituto de Tecnologia de Alimentos não mede esforços para se manter como referência no setor alimentício, não só no Brasil, como no mundo. Por entender a importância da inovação e segurança de alimentos, bebidas e embalagens para o consumidor, o ITAL pesquisa e presta assessoria técnica, visando a eficácia e padrões mínimos de qualidade. Além de estar atento aos diferentes perfis de consumidor, o Instituto atua sempre com ética e respeito ao meio ambiente, priorizando a análise crítica para acompanhar a evolução tecnológica e de mercado. As atividades do ITAL são divididas em 3 grandes áreas. A tecnologia é desenvolvida e aplicada nas unidades especializadas em carnes, cereais, chocolates, balas, confeitos, produtos de panificação, laticínios, frutas, hortaliças e engenharias de processo. A ciência e a qualidade são prioridades dos laboratórios de análises químicas, físicas, sensoriais e microbiológicas. A embalagem é o foco dos setores especializados em materiais metálicos, vidros, plásticos, celulósicos e para distribuição e transporte. E o conhecimento vai além dos muros da instituição através de artigos, publicações e eventos. O ITAL valoriza as pessoas que são força de trabalho e razão de existência. Por isso, está presente em importantes programas de governo que abrangem todas as classes e diferentes gerações. São décadas de constante reinvenção, aprendendo e ensinando, décadas de reconhecimento com a bagagem do passado e a modernidade do presente. Com funcionários qualificados, clientes, parceiros e fundações de apoio, o ITAL tornou-se fundamental no setor de alimentos, bebidas e embalagens.
Each time there is a contamination in food or beverages, the public is made aware. What they don't see is you, mitigating risks every day, taking difficult decisions and making our food as safe as possible. Because you take your job as seriously as we do. With over 350 years' experience in highly regulated industries, we understand the importance of reliability and efficiency in your lab. So be it to verify existing methods, stay on top of changing regulations, or to adopt the newest technologies. You can find it all on sigmaaldrich.com. Tailored products for each step of your workflow available on our website. We have products that are suitable for microbial and analytical needs in the crucial step of sample preparation. We have solutions for the most routine sample analysis to advanced genetic detection, such as the Assurance GDS for rapid pathogen detection, often used to test for E. coli in beef. And we support you with a complete set of services and specialists. Our experts are here to improve your day-to-day work with 4 dedicated portfolio brands: Millipore, Sapelco, Sigma Aldrich, and MilliQ. All these products can easily be ordered on our website so that you can focus on making sure that every sip, every bite is safe because it's been tested by you.
good morning, good afternoon, and good evening. Welcome to the second day of the Latin American subcommission of the International Commission on Microbiological Specification for Foods webinar on update on food safety. I am Janet Luna from TFC Colombia, and together with my colleague Francisco Garces from Colombia too, we will share today's webinar. The webinar completes 3 modules. With talks presented by the members of the ICMSF. Yesterday, the subject was related to use of data for assessing process control. Today, the topic will be microbiological criteria for product acceptances, and tomorrow will be focused on COVID-19 in the context of food safety. Tom Ross is not able to participate today. The lecture will be, all lectures will be able a few days, included the Tom Ross talk. Francisco?
Let's start the second module of this webinar focused on microbial criteria for product acceptance. We ask you to take active participation, sending us your questions through the Google form available at the chat window of YouTube. We will do our best to discuss them during our question and answer time. The first speaker today will be Dr. John Donaghy. Thanks, Dr. Donaghy, for taking part in this webinar again. Dr. Donaghy is an ICMSF member since 2015, head of food safety and corporate quality in Nestlé in the Switzerland, and current responsibilities include global operational aspects of food safety microbiology, hygiene, allergens, and other prerequisite programs across factories and multiple food categories. Worked for many years as project leader in food safety microbiology at the Agri-Food and Bioscience Institute in Ireland. Today, he will talk about application of principles to dairy products. Please, Dr. Donaghy, you can start.
Okay, good morning, good afternoon, everyone, and hope the slides are okay and everyone can hear me clearly. And thank you very much, Janice and Francisco, for the kind introduction. And as Janice has said, today's webinars will primarily talk about the application of principles for the establishment of microbiological criteria across a range of different product commodities. And I will start the session by talking specifically about the principles governing establishment of microcriteria for dairy products. A lot of the information related to my talk today can relate back to book 8 and in particular chapter 23. In this, we actually talk about the general principles, how to establish microcriteria in dairy products. So if you want more information following this talk, you can go to book 8 and chapter 23. But one of the key requirements for setting of microbiological criteria is understanding the ecology of that particular commodity. And if you look, for example, to our book 6, one of our earlier books in ICMSF, you will see there we talk about the microbial ecology of a lot of different food commodities. And in that chapter 16, we talk very much about milk and dairy products, because it is important to understand the microbial ecology before we start thinking about what microcriteria we should set. And even to update you further, it's always useful to look in the literature. And if you look at the bottom of my screen, you will see a couple of very recent reviews and scientific papers alluding to, let's say, an update on the microbial quality and safety of milk and milk products in the 21st century, and another one, a 100-year review of microbiology and safety of milk and dairy products. These are really good modern reviews that actually trace back the ecology of dairy, milk and dairy products. Now, when we think of milk, just to give you a little bit of an overview of where my talk will go. Firstly, I'll talk a little bit about the diversity in dairy products. As you can imagine, when we talk about milk and dairy products, the range of products that are in this category is very, very wide. I'll also go into a little bit of depth about the microbial ecology of milk and dairy products and how that can influence the establishment of microbiological criteria. And then, of course, I will go into some of the epidemiological links between dairy products and foodborne outbreaks. And again, that also influences the establishment of microbiological criteria. And then finally, I will take you through a few examples of specific dairy commodities and how microbiological criteria can be applied right through the food chain, from ingredients through process environment and up to finished product. So that gives you sort of a flow of where my talk will go. When we talk about the first bullet point, diversity of dairy products, this is a very diverse field. And as Francisco has said, I work for Nestle. So Nestle is embedded in dairy products. In fact, it was the founding products of Nestle some 160 years ago. So when we look at our portfolio of dairy products, it really does give a fair representation of the types of products that actually may be out there, manufactured from milk and dairy ingredients. And if you look at all of those products, you will see that these products, although they're all dairy in nature, they will end up having very different microbiological criteria. And that in some ways is also influenced by the technologies and the processes used to manufacture those products. If we look at the top left-hand side of the screen, for example, you'll see products that are commercially sterile. These are products that are subject, for example, to UHT, ultra-high temperature. So in some ways, there is little or very little, or the risk of microbial hazards is minimized greatly because of the technology applied. If I look at the extreme right-hand side, then we have things like dairy products, which are for infants. So this is infant powder, for example, infant formula. And this is a product that is not by nature sterile. It will undergo pasteurization of milk. It'll undergo spray drying, etc. But it's not a sterile product per se. And yet this is a product that actually is fed to, you might say, a vulnerable population, such as infants or neonates. So you can imagine the microbiological criteria that's going to be applied to something on the right-hand side will be very different from what is applied to the products on the top left-hand corner. And then in between, you have all sorts of technology. We just have a simple pasteurization process, for example. You have fermentation. You have different forms of ingredients. In some cases, your ingredients are added as what we call dry mix ingredients. So in other words, there is no kill step during manufacturing. So you rely on your suppliers, for example, to have the kill step at their processing facilities. And so the specifications, or the microbiological specifications of those dry mix, will have to match the microbiological criteria of the finished product. But then, for example, if we have wet mix ingredients, we know that we have processes in our manufacturing facilities which will attribute a microbiological kill to those raw materials or to those ingredients. And so that will also influence the microbiological specifications that we will set for our suppliers. So you see, it is not one size fits all when we talk about dairy products in terms of trying to establish microbiological criteria for the finished product, or even microbiological specifications for our suppliers. So that sort of highlights, let's say, where technological aspects and manufacturing process can actually have an input into, or is one of the principles governing how we set microbiological criteria for finished products. Another area is epidemiological studies. We have to understand which products are associated, with particular pathogens or with pathogens in general. And I think everybody will know, if anybody who's a microbiologist, in the audience, if I ask you, eggs, what pathogen do you think of? You'll probably say, yes, salmonella. If I say, listeria, you might say, liver pate or soft cheeses, etc. So generally there is combinations, and that is all because there is a link between the epidemiological evidence of where there's been foodborne illnesses and that particular commodity. And here is an extract, and it might look a little bit complex. I'll try to explain the complexity of it from EFSA. And this is around what are the biggest contributors among dairy products to microbiological hazards or foodborne illness cases or foodborne illness outbreaks. So if you look on the left-hand side, you have, I think it is 9 colors, okay? So you're starting from yellow, yogurt, right down to butter on the bottom. So if you actually, and then on the right-hand side, where I have a black arrow called pathogens, that part of the arc is that they lead to microbiological incidents. So if you take yogurt, for example, up near 12 o'clock, it is a yellow. You trace that yellow and you come the whole way down to the arc. You see it's a very thin line, relating to to pathogens. So that would indicate that yogurts are generally not associated with foodborne illnesses. But the thing to notice is if you look at the left-hand arc, which really runs from about 6 o'clock up to 9 o'clock, it is predominantly cheese, and that is very wide, and it's involved in a lot of foodborne illness and foodborne outbreak. So you can see very quickly from a graphic like this, and I know it's based on European studies, that the main causes of foodborne disease related to dairy products tends to be cheeses, it tends to be raw milk products, maybe some recontaminated processed milk, and then you have some mixed dairy products involving cream. And that's probably no big surprise to anyone, but it's good to have actually the epidemiological data to support where do I need to put my efforts in terms of controlling foodborne pathogens with respect to dairy products. So now I'd like to just sort of take you through a little bit more of a deep dive on some of these linkages and look at the major pathogens involved. Or just before I actually do this, I always like to show this slide, particularly to people who are non-microbiologists, just to show you the challenges that we have in microbiology. We are always trying to get from the left-hand side of this to the right-hand side. So this can be a complex process. I'm taking a commodity which is coming from an animal, milk. The cows and the animals are harvested, they are in the field, they are in houses, etc. The conditions may not necessarily be the most hygienic, and you have to get to a product that fulfills a microbiological criteria that is safe for the population that will consume it. And in between that, you will generally have some form of manufacturing that actually aims to reduce that microbial load. So really, it is an example of where the conceptual ICMS equation can be very well illustrated. You have your H naught on the left. You want to make sure you have as low a level of initial contamination as possible. You want to be able to reduce as much as possible. That is the delta R or the sigma R. And you want to minimize the regrowth or contamination or increase as well to be able to meet the food safety objective. So really, and dairy is no different from any other commodity in that this is really our main aim, is to get from the left, from let's say maybe a raw agriculture product, to the right, a product that is safe to consume. So if I actually want to look at some of the pathogens involved, and again, I refer you to a paper on the right-hand side that has a good review of this. Raw milk, as you know, can have numerous pathogens associated with, and it can have a high microbiological load. And this can actually be, can be worse at times, depending on the hygiene practices or the health status of the animals or the harvesting conditions of the milk, etc. So there is a number of factors that will influence, let's say, the microbial ecology of raw milk. So, and that's why raw milk inherently tends to be more of a food safety risk than milk that actually has been processed through pasteurization, direct steam injection, UHT, etc., etc. But if we look at some of the other commodities like cheese, there are some distinct linkages between cheese and certain pathogens. For example, Listeria monocytogenes, Este, Shiga toxin producing E. coli, Salmonella, Staph aureus, and Campylobacter. In recent years, we've seen some outbreaks associated with Campylobacter related to cheeses and also with milk. When we look at raw milk butter, raw milk cream, again, we see some of the same culprits, Listeria monocytogenes, Este, Staph aureus. However, when we move to milk powders, for example, which is more dry, let's say, products, which will generally not support the growth of Listeria, we generally do not tend to see listeria associated with milk powder and milk powder products. But here it's more associated with salmonella. As we know, salmonella can persist in low moisture environments for a long periods of time, and it can survive for long periods of time in these sort of milk powders. Also, we see some instances of Staph aureus. Then we actually see Bacillus cereus can be an issue, depending on storage conditions, you know, of cream and some other milk products as well. And we have to consider both the enterotoxins and the emetic toxins that can be produced by Bacillus cereus. And of course, we have Chronobacter, which is specifically linked with powdered infant formula. And then in some situations, depending on the countries involved and depending on how some of these diseases are controlled and managed in the country. For example, you may also have brucella, brucellosis in animals, and so you may have brucella associated with your milk, and again may lead to some foodborne illnesses. Or you can have TB, tuberculosis, if you have a high endemic level of Mycobacterium bovis in your milk. And then you have almost, and sometimes more recently, you've heard of sort of emerging pathogens like Coxiella burnetii. But these are more foodborne illness as such, and linked directly to the consumption of the dairy products. And if you look again, I mentioned that the link between, let's say, unpasteurized, or the risk of unpasteurized versus pasteurized. And again, here, if you look, for example, at some of the data from the US over the 5-year period, 2009 to 2014, you can see clearly that there's a lot more outbreaks associated with unpasteurized products, compared to pasteurized products. And when you look at pasteurized products, you can see that the big link here tends to be Listeria monocytogenes. And again, going back to the European data, you see that cheeses are very often associated with Listeria outbreaks. And if you have cheeses then that are unpasteurized, then of course you increase the risk. And these are all epidemiological evidence that helps to support how we establish the microbiological criteria in our finished products. And again, just look quickly through this slide, you will see some of the cheese and Listeria outbreaks that have been associated. A lot of them is to do with either cross-contamination, at retail or maybe in the home. It also can be during manufacturing, for example, poor GMP, poor hygiene conditions. You have poorly designed equipment, which allows Listeria to grow and build up in harborage spots, etc. And of course, you also can have Listeria, which tend to be ubiquitous in the environment. So you can have it coming from farms as well into your manufacturing process. So there is definitely, with cheeses, there is a clear link between cheeses and listeriosis. For other dairy products, for example, ice cream, there is probably less links associated, and ice cream is viewed as a low-risk product with regards to Listeria. But nevertheless, we saw a few years ago the large cases in the US associated with a commercial ice cream product, which was actually being fed to patients in the hospital. In this case, it ended up 10 cases, and 3 of those people actually died. And again, it was low levels of Listeria in the product that led ultimately to this illness. But upon the FDA investigation, a lot of it pointed towards these poor GMPs. And some of the topics like I talked about yesterday, environmental monitoring, zoning, cleaning, sanitation, etc., were not as they should have been. And so Listeria was allowed to develop in hard to reach places. It was allowed to become persistent, etc. Ultimately ended up in the finished product and led to some illnesses. But I would say that this is not a typical scenario of a link between ice cream and Listeria. It is more cheeses are more associated with Listeria and foodborne illnesses. If I move then, for example, to dry products, away from wet products, let's say cheeses and ice cream, dry products, as I say, the main pathogen that we see here is Salmonella. And I give you here some examples of, where some surveys have been done in the past, particularly even on a very sensitive milk powder, like powdered infant formula. And you can see on the left-hand side, the bottom left-hand corner, even up to 2005, you can see these incidents of salmonella being found in powdered infant formula. And what is interesting to note here is that one of those that was in that review, published in about 2006 or 2007, you will actually see there was a Salmonella agona in France, 2004 until 2005. Well, in 2017, the same company who bought the factory that was associated with that Salmonella agona had a number of links to illnesses. And as a result, they were able to determine that through whole genome sequencing, that the same isolates that were in the plant in 2005 were the same as those that were in the plant in 2017. So clearly, it demonstrates that Salmonella can survive and persist in dry factories for a long time. And it goes back to what I said yesterday about environmental monitoring. It is key that this is there as an early warning. And again, in 2019, there was another number of other cases associated with Salmonella and infant formula, rice-based infant formula, again in France and surrounding countries. So clearly, Salmonella is a pathogen, let's say, of concern when we speak about dry milk powder, and that's where that influences that it has to go into our product criteria. However, there is some other organisms which should not be forgotten about. And for example, Staphylococcus aureus and Staphylococcus aureus enterotoxins still should be one of the things should be brought to bear. You may all recall the milk company in Japan called Snow Brand. And in the year 2000, you can see from the graph, there was a massive spike in the number of illnesses related to Staphylococcus aureus enterotoxin. And again, this was related to rework of milk powder, in which case the milk was allowed, Staph aureus was allowed to grow. It was dried down, and it was later reused, and the enterotoxins, obviously were heat stable and survived the subsequent processing steps, and this led to illness. So Staph aureus is something I think is that we mustn't forget about. Sometimes we know about Salmonella, but Staph aureus and its toxins we must still consider. And I just show a couple of recent papers, one of them is even from Brazil, that actually still highlights some of these issues that still are of concern in dairy powder processing plants, and also some links to some cheese samples relating to Staph aureus food poisoning. So again, this is the epidemiological evidence that influences what must go into our product specifications. The last topic that I want to talk in this section is about another organism, Chronobacter. And again, this is an interesting example because Chronobacter, per se, is not a pathogen of dairy products. However, it was shown up till about the mid-2000s that there was a number of cases linked to illnesses in newborn and infants related to enterocolitis, necrotizing enterocolitis, and it was there was a clear link between Chronobacter presence in powdered infant formula and this illness in these babies. So as a result of that, GEMRA did a risk assessment, and in that risk assessment, they came with the conclusion that Chronobacter should be included as a sort of pathogen of concern for infants, highly vulnerable up to 2 months, and even vulnerable up to 12 months of age. And so it was recommended that specifications should be set. So based on that, the specifications in powdered infant formula changed from, you can see what was in 1979 codex, there was no mention of Chronobacter or what was known then as Enterobacter sakazaki at all. But after this risk assessment, looking at all the epidemiological evidence, it was clear that this should actually be, that we should have a parameter within the specification, and at this stage it was called Enterobacter sakazaki, later changed to Chronobacter species, of N equals 30, absence in 10 grams. So really, subsequently, that in a way forced all of the manufacturers to start to address this Chronobacter when you're producing infant formula. So it's a nice example of where specifications can actually change, product specifications can change over time as a result of these risk assessments. You may remember yesterday Marcel talked about Campylobacter, and he talked about the introduction of this sort of the specifications into Campylobacter, and how even over a period of time this will become more stricter and more stricter. So it gives the industry an opportunity to change going along. So now I'd just like to take you through a few examples, and I will take you through processed milk, ice cream and dried powder to show what we do in chapter 23 of the ICMSF book 8, and show how we actually illustrate what should be set at various steps of the food chain, that is from the critical ingredients through to in-process controls, process environment, and finally finished product specifications or criteria. And we will look at what food safety criteria, what process hygiene criteria should be included, or what utility microorganisms should be included. So in this chapter, you know, it really does go into the detail of all of the different dairy commodities or the dairy products, and does illustrate what is the recommendations for finished product specifications or also for critical ingredients. So if I go through quickly for ice cream, for example, beginning with processed liquid milk. Well, again, as I mentioned earlier, processed liquid milk, you know, what does that mean? You know, it can be pasteurized milk, it could be UHT milk, for example. And generally, for raw milk used in these processes and in the processing environment, we don't do an awful lot of, or don't recommend an awful lot of microbiological testing. We have to assume that our microbiological hygiene is under control. But if, for example, and this is where we see the medium here, if, for example, I'm producing commercially sterile milk product, so it's going to be processed as UHT, my big issue is not a safety issue, but it is more about spoilage and quality issue during the long shelf life of such products. So it may be that you may decide to introduce a specification to your supplier around mesophilic or thermophilic spores, because if you have a high load of spores, you have your UHT and you may get survival of some thermophilic spores, for example, then you have spoilage afterwards. So you will see very much you adjust what you may need in your ingredients based on the way in which your milk is being processed. And then when we look, for example, at the finished product, you will see generally in milk, the only really parameter that we include is EB with case 5. So an N5, C equals 2, small m less than 1, big M5. And I just show, and I do this for all of the different product categories, I show here on the right-hand side some of the regulatory norms that have been established for processed liquid milk, pasteurized milk, and you will see here generally, if I look at somewhere like Europe, EB, Brazil, EB, India use coliforms, Canada use coliforms, Australia use E. coli. These are all, let's say, the hygiene indicator. And you will see, if you look at the performance of any of these sampling plans, they are not greatly differing from, let's say, from each other or from what was recommended by ICMSF. So almost this is a nice illustration that many of these countries are looking at ICMSF and looking at the case that is recommended, the organism that is recommended to be tested, and looking at the parameters that are involved. So this is a nice example for where ICMSF sort of case studies have been transferred into very regulatory norms. If I look, ice cream is a little bit similar. And again, ice cream, it's a pasteurized product. It's going to be a frozen, ready-to-eat product. Some of the things which we have to consider in our raw materials, because a lot of ice cream is not just a simple dairy product that's been pasteurized. A lot of them will have inclusions. So this is a watch-out point. If, for example, we are adding nuts, we are adding fruit, etc., inclusions to this product, we have to make sure that those ingredients do meet the specification of our finished product. Because if someone is eating ice cream as a ready-to-eat product, of course, then the raw material is added, as I say, as a dry mix. So it's added as a critical ingredient. We have to make sure with our suppliers that they're able to meet a specification that would be similar to our finished product specification. In terms of the processing environment, as I discussed yesterday, again, Listeria is the organism generally of concern, Listeria monocytogenes, but of course also Salmonella, but you definitely have to include Listeria. And again, Listeria species is quite often included as your hygiene indicator. But when we look at the finished product, you will see again, if I look at some of the regulatory values and I look at some of the recommendations that are made by ICMSF, again, you can see they are quite similar. In Salmonella, there's some difference because there could be an N equals 10 instead of N equals 5 for Salmonella. But you will see in some of the legislation, you will see N equals 5 for EB, small m10, large M100 with a C value of 1. You see Staph aureus is also introduced there with a small m of 100 and a large m of 1000. These limits are very much aligned with what is recommended by ICMSF. And you can see, and here, Europe and Brazil, are very, very much aligned, even in terms of the hygiene indicators, but also the key pathogens. If I move now to the dry products, and again, this is a little bit the same as I mentioned before, and I mentioned yesterday, environmental monitoring. The key pathogen here is Salmonella, perhaps also Staph aureus, and the key indicator, hygiene indicator, is EB or perhaps coliforms. And you will see some of these is involved in the monitoring, in process control and the processing environment, and also included, for example, as a total count, EB, and you will see again in the end product testing, you will generally see a total count, of 10 to the 4, generally, 1 by 10 to the 4 for small m, 5 by 10 to the 4, so for the big M, for APC. Again, you see the Salmonella is there, EB is there, and again, you look at the limits, they're very much aligned with the recommendations of ICMSF. As Marcel said yesterday, ICMSF only makes recommendations. The regulatory authorities, you then are free to, let's say, put in place the case studies, the parameters that they so wish. But it acts as a good guidance, and it should act as a sort of, they should follow the principles for establishing the key organisms and the key limits and the key case studies, as Leon mentioned yesterday, as part of the 15 case studies of ICMSF. So again, you see here, Europe, Brazil, very much aligned in terms of the case studies and very much aligned in terms of the limits that have actually been set for dry dairy products. If I move now just finally to powdered infant formula, which you might say is a special form of dry dairy powder, because of the population that it's meant for. This is typically the production process of powdered infant formula. You have a wet part where you have your CCP. So if your milk comes in, you have your CCP, pasteurization, direct steam injection, etc. You then tend to have, some ingredients that are added at maybe at the same stage for the heat treatment, or perhaps afterwards. And then you have what we call the spray drying, which would be viewed as the dry area. Okay, and remember yesterday we talked about, in the dry areas, we will be sampling a lot for Salmonella, Chronobacter, and our EB in this dry environment, because that's the pathogens of concern and the hygiene indicators that are good to measure. Also, if we add dry mixed ingredients, and often in powdered infant formula, manufacturers will add vitamin mixes and some other elements, to the product matrix, prior to spray drying, but after the CCP. It is vitally important then that the specifications of those dry mixed ingredients are the same as the finished product. So if, for example, we go back to what was set by Codex recommendations and set by a lot of authorities now, this is the criteria. The total count is this: a small M500, large M100, large M5000, EB, absence in 10 grams, 10 samples, and you see you have Salmonella N equals 60, and you have Chronobacter species or Enterobacter sakazaki N equals 30, absence in 10 grams. So if I am buying, for example, so that's my finished product spec. If I am buying material like on the right-hand side, which is my dry mixed material, it is clear I will have to set this specification for those raw materials, because these materials will be added direct to my finished product. So that's in some ways indicates this link between finished product specification or criteria and specifications that will be set by a manufacturer to their supplier. So that's why we will buy material like this from suppliers, and suppliers will know our requirements and they will have to meet the requirements of the finished product criteria because they are being added as a dry mix. Again, if I look at this specification, that is very similar to the Brazilian regulations around infant formula. The Brazil regulations also add in Bacillus series with, you see, an N equals 5, C equals 1, with an upper M of 500 and a small m of 50. So again, each regulatory authority is they have the independence to include whichever parameters, but we hope that they consult with something like ICMSF to guide them in terms of what case study they should use and what limits should be put in place. So just to conclude, as I always say in any of these talks, is Codex sets the principles, and some of the principles I alluded to: ecology, epidemiology, processing, technology, etc. So Codex sets these sort of principles. ICMSF expands with recommendations. I always say Codex is a skeleton, ICMSF puts meat on the bones, but then an authority can decide, how stringent or how strong those muscles on the bones can be. So, and I think reiterating what I said yesterday and what Marcel and all the other speakers said yesterday, product testing has severe limitations. And I always say a microbiological criteria is something that has to be complied with. It does not mean that every batch has to be tested, against that particular criteria. You have to be able to manufacture products that will always meet that microbiological criteria. So we cannot never test safety into our products. And the bottom parts of the pyramid, which Marcel and Leon talked about yesterday, are vitally important because, as Marcel said, you end up with a house of cards, which will easily come down if you don't have what we call the 4 bullet points at the bottom of my presentation here. You don't have HACCP principles, you don't have good prerequisite, good manufacturing practice, etc. in place, and you don't have good environmental monitoring, and you don't do good root cause analysis when you have incidents, then your house of cards can fall down easily. So you do not rely on microbiological testing to assure food safety is my take-home message. Okay, so that concludes, and I hand back to you, Janet. Or Francisco.
Thank you very much, Dr. Donaghy, for this interesting presentation. We have some questions. The first is, what is your opinion about the need of testing E. coli STEC on dairy products?
Again, it's a risk assessment. In general, we would not, you advocate this. Certain products that are going to be processed and will undergo a heat processing conditions, generally that will eliminate any of the STEC. Of course, if you're producing raw material and STEC is prevalent, let's say on farm, and you're producing a raw material, then this, again, you look at the ecology, you look at the disease. There's been outbreaks associated between raw milk cheeses and STEC, and even with milk and STEC. So certainly if we're producing a non-pasteurized product, STEC would come into consideration. But if we're producing, for example, a pasteurized heat-treated product, then I would question why we would need STEC. Something like another utility organism or another hygiene indicator should be sufficient to assess the hygiene control of, let's say, of your supplier. If it's your supplier, you're thinking about who's supplying you with milk.
Okay, thank you. The second question is, in relation to the sampling plan for a commercially sterile product batch, N equal 60 and C equal 0, case 15, would it be reasonable for approval?
Sorry, I didn't quite get the last part of the question. The question relates to assessing verification of sterility.
Yes, for the commercial sterility product in batch.
Yeah, well, I think often there is an ISO standard around this, which does dictate the number of samples that must be taken as destructive samples and non-destructive samples. Sometimes the application of that ISO standard can be quite severe for manufacturing. So, again, you can introduce, maybe a risk-based approach in terms of the number of samples. Within Nestle, we have a certain regime of the number of samples we take for destructive testing and for non-destructive testing, like, if you're just measuring pH or you're doing actual microbiological, streaking or using ATP bioluminescence, that will be sort of a personal, sort of a company's own decision as to what degree of an amount of testing they will do. The ISO standard is quite stringent and requires taking a lot of samples. But, I would say you must also take into consideration the historical nature of your line as well. How much process control do you have? If you have good process control, then the number of samples taken, of course, can be modified accordingly.
Okay, thank you. And the last question is, what is the relationship between the persistence of Salmonella and to biofilm formation on dried surface? How have the industries been monitoring these biofilms?
It's not something that we would monitor on a regular basis, but obviously biofilms are of concern to the food industry, and biofilms can be formed by many different organisms, including some of the pathogens, including the likes of Listeria, Bacillus, and even perhaps Salmonella. However, I would say rather than looking specifically at the biofilm formation, what we look at is the efficiency of our cleaning processes and sanitation processes. So, for example, what we say in terms of, as part of our GMP, we will have a strict master sanitation program. Within that, we will have key aspects of our lines and our environment that we must clean. And for that cleaning, we must adhere to certain acceptance criteria. So that might be, in this case, for microbiological, criteria. And we will then be able to monitor that and verify that through like ATP monitoring. So, what we will do is be very strict on the validation of our cleaning process so that we validate on the worst case scenario, that is a line that may develop biofilms or some maybe a possibility of biofilms forming because of its design or because of the flow rates, because of the nature of the material going through. So we will always establish our validated cleaning based on, we try to pick the worst case scenario. And then, of course, we will then look at our ATP results as our verification of cleaning. If we start to see deviations in our ATP, then of course we will question, do we need to revalidate? Why is it taking longer to clean than before? Is this because biofilm development, etc.? And that would be part of your investigation. But we would use triggers like, for example, deviations in our monitoring or our verification data to then look further and see, would biofilm be one possible root cause? Because biofilm may only be one possible root cause of, let's say, deviations in our line.
Thank you very much, Dr. Donaghy, for participating in this interesting discussion session. We will have now 15 minutes for coffee break. Please come back at 10:30. Thank you.
Okay, thank you, everyone.
O FORC é um centro de pessoas, que é um centro que agrega pessoas que trabalham, que desenvolvem pesquisa aplicada em diversos pontos da ciência do alimento e da nutrição.
Já se pensava em fazer um centro de alimentos dentro da USP. E a gente achava que a USP, se ela unisse todos os fragmentos, todos os grupos que trabalham com alimentos numa única coisa, nós ficaríamos invencíveis.
Por que não? por que não fazemos esse projeto, né? E aí nós começamos a conversar e foi um longo processo, porque foram 2 anos para a FAPESP decidir que nós tínhamos expertise suficiente para ter um centro.
A ciência do alimento, a ciência da nutrição, ela é multidisciplinar por definição. Então eu costumo brincar sempre que o mundo tem 9 bilhões de especialistas em ciência de alimentos. Todo mundo entende de alimentos, porque o FORC é um centro de pessoas, que é um centro que agrega pessoas que trabalham, que desenvolvem pesquisa aplicada em diversos pontos da ciência do alimento e da nutrição.
Já se pensava em fazer um centro de alimentos dentro da USP. E a gente achava que a USP, se ela unisse todos os fragmentos, todos os grupos que trabalham com alimentos numa única coisa, nós ficaríamos invencíveis.
Por que não? Por que não fazemos esse projeto, né? E aí nós começamos a conversar e foi um longo processo, porque foram 2 anos para a FAPESP decidir que nós tínhamos expertise suficiente para ter um centro.
A ciência do alimento, a ciência da nutrição, ela é multidisciplinar por definição. Então eu costumo brincar sempre que o mundo tem 9 bilhões de especialistas em ciência de alimentos. Todo mundo entende de alimentos, porque todo mundo come. Existe uma frase famosa do Luiz Fernando Veríssimo: o poder acaba, a visão acaba, o sexo acaba, mas a fome continua.
Uma das coisas que a gente realmente mostrou é que esse tema tem uma importância capital para o país. 30%, quase 40% do nosso PIB vem justamente desse setor, do setor da agricultura, do setor de alimentos. E isso daí tem um reflexo direto, nutrição, para a população.
Nós podemos, em parceria com a indústria, desenvolver projetos que sejam cientificamente de alto padrão, aplicáveis para a indústria que beneficia a sociedade.
A pós-graduação é importantíssima porque a maior parte justamente de toda a pesquisa que é feita, ela é feita no laboratório por pós-graduandos. Quer dizer, os mestrandos e doutorandos, eles formam a maior parte, vamos dizer assim, dos nossos recursos humanos. Um recurso humano altamente especializado.
Hoje nós temos no FORC 30 jovens pesquisadores trabalhando com a gente e nós conseguimos chamar inclusive pesquisadores do exterior.
A gente percebe que existe um avanço considerável em quantidade e em qualidade também.
Uma das coisas que também a gente quer muito é que a gente tenha essa parceria com universidades e institutos de pesquisa mundiais que trabalhem com alimentos e nutrição. E isso está acontecendo de maneira bem forte.
Se vier uma indústria aqui dizendo que quer desenvolver alguma coisa, quer aprofundar um determinado tema, nós temos as competências aqui para ajudar.
Dentro de uma universidade, dentro de um laboratório, você tem a condição de trazer aquilo lá, aquela ideia, torná-la realidade. E por isso que nós somos apaixonados pelo nosso trabalho.
Eu acho que inovação é quando você vê alguma coisa de um jeito diferente do que os outros veem.
Nós criamos lá embaixo um laboratório que é de primeiríssimo mundo e a gente consegue fazer pesquisas de altíssima qualidade.
Essa é a nossa pretensão, que a gente tenha um centro de pesquisas dentro da Universidade de São Paulo que seja independente.
Consolidar o grupo e ir para frente daí. Se tornar uma referência dentro do universo de alimentos e nutrição para o país e para o mundo.
Nós queremos continuar formando gente muito boa, mas nós queremos formar gente muito boa e produzir ciência muito boa. E como é que a ciência é muito boa? A ciência do 1970 não serve mais. A ciência do 2017 hoje ela é toda integrada, ela é toda colaborativa, ela é toda multidisciplinar, ela é toda sinérgica. O nosso centro ele está no momento certo funcionando dessa forma.
Olha, aquilo que está na nossa missão, viu? Ciência para melhorar a vida.
Each time there is a contamination in food or beverages, the public is made aware. What they don't see is you, mitigating risks every day, taking difficult decisions and making our food as safe as possible. Because you take your job as seriously as we do. With over 350 years' experience in highly regulated industries, we understand the importance of reliability and efficiency in your lab. So be it to verify existing methods, stay on top of changing regulations, or to adopt the newest technologies. You can find it all on sigmaaldrich.com. Tailored products for each step of your workflow available on our website. We have products that are suitable for microbial and analytical needs in the crucial step of sample preparation. We have solutions for the most routine sample analysis to advanced genetic detection, such as the Assurance GDS for rapid pathogen detection, often used to test for E. coli in beef. And we support you with a complete set of services and specialists. Our experts are here to improve your day-to-day work with 4 dedicated portfolio brands: Millipore, Sapelco, Sigma Aldrich, and MilliQ. All these products can easily be ordered on our website so that you can focus on making sure that every sip, every bite is safe because it's been tested by you.
Uma história que começou em 1963. Com décadas dedicadas ao desenvolvimento de processos, produtos e embalagens, o Instituto de Tecnologia de Alimentos não mede esforços para se manter como referência no setor alimentício, não só no Brasil, como no mundo. Por entender a importância da inovação e segurança de alimentos, bebidas e embalagens para o consumidor, o ITAL pesquisa e presta assessoria técnica, visando a eficácia e padrões mínimos de qualidade. Além de estar atento aos diferentes perfis de consumidor, o Instituto atua sempre com ética e respeito ao meio ambiente, priorizando a análise crítica para acompanhar a evolução tecnológica e de mercado. As atividades do ITAL são divididas em 3 grandes áreas. A tecnologia é desenvolvida e aplicada nas unidades especializadas em carnes, cereais, chocolates, balas, confeitos, produtos de panificação, laticínios, frutas, hortaliças e engenharias de processo. A ciência e a qualidade são prioridades dos laboratórios de análises químicas, físicas, sensoriais e microbiológicas. A embalagem é o foco dos setores especializados em materiais metálicos, vidros, plásticos, celulósicos e para distribuição e transporte. E o conhecimento vai além dos muros da instituição através de artigos, publicações e eventos. O ITAL valoriza as pessoas que são força de trabalho e razão de existência. Por isso, está presente em importantes programas de governo que abrangem todas as classes e diferentes gerações. São décadas de constante reinvenção, aprendendo e ensinando, décadas de reconhecimento, com a bagagem do passado e a modernidade do presente. Com funcionários qualificados, clientes, parceiros e fundações de apoio, o Itaú tornou-se fundamental no setor de alimentos, bebidas e embalagens.
Welcome back for the second part of today's webinar, Microbial Criteria for Product Acceptance. Our next speaker is Dr. Michelle Daniluk. She is the ICMSF Treasurer since 2018 and member of the Commission since 2016. Professor and Extension Specialist of Food Safety and Microbiology in the Department of Food Science and Human Nutrition at the University of Florida in the United States. Her current interests include microbial food safety and quality, particularly of fruits use, fresh fruits, vegetables, and nuts, focusing on HACCP and good agricultural practice. Dr. Daniluk will talk about the application of principles for fresh products. Dr. Daniluk, you can start and you will have 30 minutes for your presentation.
Perfect. Thank you so much, Francisco. Good morning, good afternoon, and good evening, everyone. Thank you so much for joining us. I'm going to follow up John's talk about dairy products with talking about applying the ICMSF principles to fresh produce. And similar to John, when he talked about the wide variety of different products that fall into the dairy category, there's also a wide variety of products that fall into the produce category, foods other than nuts, grains, and some legumes that are derived from plants. So things like fruits, vegetables, some different fungi. There's certainly the mushroom family, and then all the seeded sprouts or sprout seeds. And so they're a tremendously important part of the diet. A great source of nutrients and vitamins, and certainly we have over the last several decades seen an increase in their consumption, especially an increase in their consumption as a raw product, and certainly encouraged to be consumed as a raw product. But with that increase in consumption as a raw product, we've also seen an increase in the number of foodborne outbreaks that have been associated with produce products. And so this is data coming out of the United States, and it's data of outbreaks associated with produce between 2010 and 2017. And so similar to John and how he discussed, we need to sort of look and see what dairy products are leading towards the most outbreaks. Similar also with produce, which produce products are leading to the most outbreaks. And so you can see here we have a bunch of different commodities that have led to a number of outbreaks in the United States since 2017. And I'll point out when we look in this category, sprouts really fall out the highest at 19%. Of outbreaks. Now, I've taken this data, and this is me looking at it a little bit differently. So I've removed sprouts from the equation, and that's because in general, sprouts are produced under very different conditions than a lot of the other produce products. They're grown primarily indoors in an environment that can be treated a lot more like a manufacturing facility than these other produce products that are grown typically outdoors, where there's a lot more variables to control. And the other thing I've done when I move into this category is previously it had leafy greens broken out into different categories of leafy greens: romaine lettuce, other lettuces, leafy herbs. And here I've sort of put all the leafy greens into one category. And so when we look at it this way, then almost 40% of the outbreaks in the United States between 2010 and 2017 have been caused by some sort of leafy greens, and then followed by a number of other commodities, some that are reoccurring when we look at produce outbreaks going back further decades, and some that are sort of emerging as newer areas that historically hadn't been associated with outbreaks. So certainly melons are something that have been involved in produce outbreaks many times before. Papaya is a relatively new one, and this number of outbreaks is driven by outbreaks in the United States of papayas imported primarily from Mexico, a reoccurring issue with salmonella. New to this list from previous decades is cucumbers. We've seen an increasing number of outbreaks in the United States associated with cucumbers. Getting smaller in its sort of input into the number of outbreaks are tomatoes and tomato-like products. And then we see mangoes and peppers, which have been associated before, and then a large category of others, which include sort of a commodity that maybe showed up in one outbreak, but not multiple outbreaks. And when we look at ranking these numbers in different ways, this is another paper out of the Centers and Disease Control in the United States. It's looking at an overall surveillance of foodborne disease in the US between 2009 and 2015 And what they did is they looked at different food categories and then the number of outbreaks and the number of illnesses that were associated with each of these categories. And so I've sort of highlighted there at the beginning, aquatic animals, 344 outbreaks, land animals, 565 outbreaks. And then I also brought up plants, which has almost as many outbreaks associated with these plant-based products, such as all the produce items I've talked about it, 334 outbreaks. So a pretty significant number of outbreaks. But shocking, if you look at the aquatic animals, so seafood, where the number of outbreaks is more, when you look at the plant-based food outbreaks, almost 10,000 illnesses associated with these produce outbreaks. And really, that's driven by the distribution and the way plants are distributed, and very much so the lack of control and the lack of processing in a lot of these products, where there is very minimal number of things that can be done to manage microbial food safety after production. So pointing out some different types of plants below, you can see the sprouts, again, 21 outbreaks in that case, 766 illnesses. Root and ground vegetables, again, 20 outbreaks, 383 cases. The seeded vegetables, so that in this category is all our Solanaceae crops, tomatoes, eggplants, peppers, things like cucumber grown on a vine. The next one I want to point out is the vegetable row crops. This is how the group at CDC classified our leafy greens and stems. They all fell under the vegetable row crop category. And then finally, you can see fruits with a huge number of outbreaks associated with them, 78 and almost 2,500 people sick. And that includes palm fruits like apples, all the melon, small fruits like berries, and our tropical, subtropical, and stone fruits all fall into that fruit category. So tremendous burden of foodborne disease associated with these plant-based products. The paper went on to categorize and rank the top 5 pathogen food category pairs, resulting in outbreaks associated with illness, again, over this period. And I've listed those, in this case, associated with illness, which is the second, this line, this column right here. And you can see salmonella and these seeded vegetables. Those are those things like tomatoes, peppers, the vine crops, very, very high, 25 outbreaks, second highest number of illnesses associated with it. When we look at the top 5 pathogen pair resulting in hospitalization, 3 of the top 5 pathogen food category pairs resulting in hospitalization are related to one of these produce products. So salmonella and those seeded vegetables, again, coming in at number 1. Salmonella and the fruit products coming in at number 3, and then Listeria monocytogenes and fruit products associated or came in at number 5 on that list. So huge number of illnesses and hospitalizations associated with these fresh produce products. And then finally, when we look at deaths, solid 4 of the top 5 pathogen commodity pairs are related to produce. So number 1 is Listeria monocytogenes associated with fruit. Again, only 3 illnesses, but 41 deaths. So a tremendous issue emerged related to Listeria monocytogenes in fruits that I'll chat through a little bit later. Salmonella and seeded vegetables, again, that's the tomatoes, came in at number 3, salmonella and fruits at number 4, and then Listeria monocytogenes and those vegetable row crops, which are the leafy greens, coming in at number 5. So again, a tremendous burden of disease associated with fresh fruits and vegetables. Now, to talk a little bit about notable outbreaks and to dive in a little bit more to that Listeria monocytogenes fruit category that is at the top, I want to talk a little bit about the produce outbreaks, or the produce outbreaks that are driving this and that are notable. And this one in particular that pushed Listeria monocytogenes associated with fruits up to the top is a cantaloupe outbreak that happened in the US back in 2011. And so this, almost a decade ago now, but a really devastating outbreak in terms of deaths. but also a really interesting outbreak for those of us that work in produce safety, because really before this, we didn't worry so much about Listeria monocytogenes on whole crops. Certainly within the fresh cut fruit and vegetable area, it was something we worried about. But when we were talking about intact commodities, and this outbreak was associated with melons that were sold as intact melons, we knew that Listeria monocytogenes could be there. We knew that, but we also didn't think that it would grow on the intact product. And so this was sort of a game changer and an eye opener for us. Again, very large outbreak in the United States, 28 different states involved, 147 people sick. Of those 147 people, 143 of them ended up in the hospital, and 33 deaths associated with the outbreak. That made it the most deadly outbreak in US history. So really, really a game changer for us. And as you'll see in a lot of the other outbreaks and a lot of what's driven the ICMSF criteria around fresh produce, we historically always looked for the source of the pathogen in fresh fruits and vegetables in the production environment. And what was really unique about this outbreak was that they didn't find Listeria monocytogenes, the outbreak strains anyway, in the produce environment. But in fact, they found them all in the packing shed. And so the picture on the right side of your screen there is what the melon packing shed looks like. This is not atypical of what a packing shed would look like in the United States for melons. At least a decade ago, things have changed a little bit since then, but still common for us to pack fresh fruits and vegetables in open air environments where we've got one wall and then sort of open to the environment on a concrete pad, perhaps. But what was unique about this outbreak was when the investigation came in to collect environmental samples, of the 39 swabs that they took, 13 of those were positive for the outbreak strain. All right. And of those 13 positive swabs, 12 of them were taken from food contact surfaces on the processing line. And so this links back to some of what John talked about yesterday in terms of environmental monitoring and its importance in seeing sort of signals coming up in the industry. And certainly in this case, had this firm been doing any sort of environmental monitoring, this is something that they would have picked up. I mean, just the sheer number of positive swabs, 12 from food contact surfaces that tested positive for the outbreak strain, is a bit astounding and was a bit of a game changer in the way we look at Listeria monocytogenes in fresh fruits and vegetables. Another really noticeable produce outbreak that many of you probably are familiar with was in the EU back in 2013, and it was related to a frozen mixed berry product, and it was linked to hepatitis A. And in this case, it was 12 different European countries and at least 1,444 cases. So again, a large number of outbreaks. And in this case, there was a lot of suspected sources, but never any published results linking to exactly what the cause of the outbreak was. Certainly in this mixed berry environment, traceback becomes very, very difficult. And in this case, different frozen items in that frozen berry mix came from different countries around the world. And so that really complicated the traceback. But what was highly suspected is that there was a single point source, and that single point source was actually something that happened during the freezing event. So again, something maybe that we wouldn't historically look at. The last notable outbreak I'm going to talk about before we get into some of the micro criteria is one that happened between March and June of 2018, March and June of 2018 here in the United States. And it was linked to romaine lettuce. In this case, there were 36 states in the United States and a number of provinces. In Canada, 210 people sick, 96 different hospitalizations, a number of cases of hemolytic uremic syndrome and deaths following back. And sort of notable about this one is how complicated the traceback was. And so on the right-hand side, I've provided the graphic that FDA developed to talk about this traceback investigation. And you can see that sort of they never were able to go back to one farm, right? So unlike the Jensen Farm situation where they were able to go back and say, really the source was the packing line, unlike the situation with the frozen berry outbreak where it really suggested a point source. In this case, they were unable to trace it back to any individual farm, instead rather tracing it back to an entire region. So this farthest right row here is all the different farms that were implicated in the traceback. And what they found was the strain in a canal. So in a water source that was being used to overhead irrigate the leafy greens, they didn't actually find it on any of the farms. So very, very complicated traceback situation. This is pretty common to what we expect in a lot of fresh fruit and vegetable outbreaks. So if we look quickly into microorganisms of concern, again, similar to the microorganisms of concern that we talked about yesterday, we worry about bacterial pathogens, we worry about viral pathogens, and we worry about the protozoa pathogens and parasites that Jeff and others talked about yesterday. So these are all things that we do worry about and we need to take into account when we start looking for hazards in fresh fruits and vegetables. There are documents, international documents out there that discuss microbiological standards out of CODIS, and like John said, sort of setting a framework to which more details can be built on. They include ready-to-eat fresh-cut fruits and vegetables, sprouts, fresh leafy green vegetables, melons, and berries. And so there is some information out there, but again, like John talked about, we do have recommendations for these products in our book 8, and these happen in both chapters 12 and 13, 12 being on vegetables and vegetable products, and 13 being on fruits and fruit products. Now, similar to what John discussed, we in the ICMSF books focus on different types of microbial testing, and a lot of the focus of the chapter on fresh fruits and vegetables talks about environmental testing and assessing effectiveness of good agricultural and good hygiene programs, practicing and minimizing ways to talk about cross-contamination. And we cover a variety of different products, including fresh and fresh-cut vegetable and vegetable products, cooked, frozen, canned, dried, fermented, acidified, sprouted seeds, and mushrooms are all covered in the vegetable chapter. And then whole, fresh-cut, frozen, canned, dried, tomato products, and fruit preserves are all covered in the fruit and fruit products chapter. I'm going to focus primarily on the fresh side of each of these, and I'm going to focus primarily on the production aspect, which is covered in both of the chapters. Again, like I mentioned earlier, there's a huge product diversity within these categories of fruit, vegetables, and produce that cover a huge range of foods. And I think important thing to remember is that we might grow the same crop in a lot of different places, but we don't necessarily grow it the same way. And so I think that plays a large part when we look at setting micro criteria, whether something is produced in a greenhouse or produced in the open air, whether it's grown on a raised bed on plastic or whether it's grown on bare ground. These are factors that really influence what your requirements may be. And so you need to really take into account cultural techniques and distribution and processing and end uses as you start looking at criteria for different products. So like I said, we're going to start in primary production. And when we look at the primary production environment for fresh fruits and vegetables, and we look back onto the farm, there are a tremendous number of sources that we need to focus on that can lead to contamination of fresh fruits and vegetables. And they include things like humans, so the workers working in the field while we're producing and harvesting the different fresh fruits and vegetables, but also potential human waste that can get into different streams of production. They include things like the soil, especially for adding some sort of a compost or soil amendment to the soil of a biological origin. They include water, which often is surface water or water of lower quality than we would find in a food manufacturing facility. Certainly it includes building equipment and tools. This links back to sort of that example I gave of the Jensen farm example. Certainly animals and animal intrusion also play a very large role in these different outbreaks. So again, when we focus on types of microbial testing in fresh produce, we typically focus on inputs into agricultural production. So we're testing inputs rather than testing products. In some products, and specifically in leafy greens and sprout products, we do some pre-harvest testing of the product itself, but we don't see that widely distributed across the spectrum of fresh fruits and vegetables. Instead, we really see a focus on testing water sources, soil amendments, and other types of samples like that. When we look at agricultural water as an input into these systems, there's sort of three different questions that I like to ask myself, or that we like to ask ourselves when it comes to assessing how risky a water might be in terms of its use of production. And those questions really are, where does the water come from? What's its source and perceived quality? And that may impact how frequently we want to test it. How is it applied? Certainly water that's applied to the harvestable portion of the crop that a consumer is going to eat is of higher risk than water that's applied in a way that doesn't contact that harvestable portion of the crop. And then certainly the timing of the application also makes a big difference in terms of water, whether you are applying the water when you're planting the crop to water in a transplant, or whether you're applying that water very close to harvest. And again, for me, some of the biggest issues are, what is the source of the water and how does that influence its probability of contamination? And again, in a lot of the produce production that I work with, our source water is going to be on the sort of right side, high risk of that sort of risk scale, where we're using a lot of surface water. We're using a lot of surface water that's open to the environment and has a lot of potential inputs of contamination into, but something you need to think about when you're testing for the water. And then again, method of irrigation works. In general, we're seeing agriculture moving towards some of these lower volume, lower use water situations, just for sustainability reasons and also for product quality reasons, because water is also a great way to spread plant diseases. But certainly if you've still got an overhead irrigation system or some sort of a flood or furrow irrigation with a high potential for splash, we still see a pretty big risk there. And then of course, the lower risk is sort of those pictures on the bottom where we've got really controlled either drip line irrigation under plastic in production, or some sort of a microjet sprinkler existing under a tree crop and sort of staying under the canopy itself. And so looking into the standards that are in Book 8 of ICMSF, it breaks irrigation water down into a couple of different categories. So it talks about irrigation water that's touching a ready-to-eat crop, irrigation water that's touching a crop that's not going to be ready to eat, and then pesticide and cleaning water, which includes a lot of our foliar sprays, things where we know that water is going to touch, again, that harvested portion of the crop. In all cases, our recommendation here is testing for E. coli as an indicator of fecal contamination. We don't make a recommendation of testing to any of the pathogenic standards. And then you can see here the NC, little m, and big M. And you can see again, that water that's being used for pesticides or other foliar sprays really has the very highest standard, where we're talking about absence of E. coli in 100 mils of water and in over 5 tests. Soil amendments are another very big concern in terms of inputs. And this is especially related to soil amendments that include raw or untreated manure. And this is also true of untreated human waste. And so certainly our synthetic fertilizers are quite a bit less risky. And the risks here, again, can be reduced by some of our basic biological or basic GAP processes of not storing a pile of manure in the middle of the field, like I show in the right in the picture on the left, and not showing a pile of manure close to your irrigation water source where there's potential for runoff, like I show in the picture of the right. When we look at testing of composted organic soil amendments, so these soil amendments of animal origin, again, general recommendation is to test for E. coli, but we also see recommendations for the Shiga-toxigenic or EHEC E. coli and for Salmonella. And you can see in the case of testing for these pathogens, again, we're looking for absence in 10 grams for both of them. This is for composted and pasteurized manures for vegetables that are being applied, for manures that are being applied to vegetables eaten raw. When we look into composted manures for vegetables not eaten raw, again, similar testing, although less important. And then when you're looking at putting some sort of a treated manure onto vegetables not likely to be eaten raw, in this case, we don't recommend any routine testing. Really quickly, moving into some of the fresh and fresh cut products. This is where environmental monitoring becomes really, really critical and important. And the thing about most fresh cut fruits and vegetables is that they're capable of allowing or supporting the growth of different foodborne pathogens. And I often joke that a fresh cut papaya or a fresh cut mango or a fresh cut tomato can grow salmonella on it better than most of my graduate students can grow bacteria in broth in the laboratory. Really, really great growth media for our different foodborne pathogens. Now, the important point I want to point out here, and if you remember nothing else from my presentation, please remember this bottom point that has been bolded. Enterobacteriaceae, coliforms, and fecal coliforms are all part of the normal microflora found on produce. You can test a produce item that's been grown in a pristine environment and still find Enterobacteriaceae and coliforms on the surface. These groups do not reflect the sanitary status of raw produce, and they are not useful as indicators of hygiene. They are there, we expect them to be there, and we expect them to be there at relatively high levels. Looking at, again, fresh and fresh cut produce, again, really important here becomes testing of antimicrobial sanitizers in wash water to prevent contamination, and that environmental testing that John talked about yesterday to prevent cross-contamination from different surfaces. When we look at testing end product testing for fresh cut fruits and vegetables, again, our recommendation is typically to test for E. coli with the standards given there. And then again, typically the recommendation is not to test for pathogens in those products. And that is true both in the products that support and do not support the growth. So I'll end with this statement again. Microbiological testing is an integral part of a produce safety program, but it needs to be used appropriately and pragmatically. And I think that if you take away that the focus here tends to be on testing agricultural inputs, not testing product in the field, except for a couple of rare cases. And that especially during packing and the fresh cut operations, your monitoring and microbial testing activities should focus on anytime you've got a water step, especially a recirculated water step that can cross-contaminate the product, and doing environmental monitoring as a verification activity to ensure good cleaning and sanitation. And then again, I'll point out this point at the bottom. Those Enterobacteriaceae coliforms and fecal coliforms are part of the normal flora on these fresh cut fruits and vegetables. And I've seen more standards than I can count where somebody's got a coliform standard on a fresh produce thing that the producer can never meet because The bacteria, those are the normal epiphytes we find on fresh cut fruits and vegetables. And so those groups being present on fresh fruits and vegetables don't indicate the sanitary status of the product. And with that, I'm at the end of my presentation. Francisco, I'll turn it back over to you.
Thank you very much, Dr. Daniluk, for your interesting presentation. And the next speaker is Dr. Wayne Anderson. Hello. Dr. Anderson is ICMSF member sign 2007, Director of Food Science and Standards, Food Safety Authority of Ireland. He served several years with Unilever Research and Latin Foods, worked with WHO and FAO on several expert consultations and represents Ireland on the Codex Committee for Food Hygiene. Dr. Anderson will talk about the application of principles to meat products. Dr. Anderson.
Thank you very much, Janice, for introducing me there. Hopefully everyone can see my slides there and not the speaker view. Sometimes that gets confused. My job really over the next 30 minutes is to take you through the recommendations in Book 8 of the ICMSF on meat and poultry testing. I work for the Food Safety Authority of Ireland, as Janice said, and that's the government body that oversees food safety in Ireland. So I'm a regulator by background, and probably my view of this is somewhat gilded by that regulator background. But I'll try and cover off some of the aids we have for industry in these matters, and some of the regulatory standards as well that apply, particularly in Europe. So I'll go through this and introduce the tables bit by bit. First off, it's probably worth looking at meat products and poultry products and where they sit in the hierarchy of foodborne illnesses. And I always like this. It's maybe a few years old now, but I like the fact that Mike Batts and his colleagues in a report called Ranking the Risks attempted to examine the risk hierarchy of product pathogen combinations, and that followed on from the work of Scallon in the CDC that looked at the impact of foodborne disease in the US. And you can see here on this particular slide, the poultry ranked first amongst all the commodity pathogen and commodities with a quality adjusted life year score of over 14,000, and meat and meat products featured in 4 of the top 6 places with a combined impact of 33,405 QALYs, which is about 50% of the QALYs that were calculated in the study of all the foods. Now, as you've heard from Michelle just now about the impact of fresh produce, I suspect that these days in 2021, this might be a little different, but I think still that you'll see that the data show that meat and meat products still are a major contributor to foodborne illness in the world. And I was interested, and I wrote some figure down here from Michelle's slide that's in the US CDC data 2009-15 for outbreaks. There were 565 outbreaks to do with meat and meat products, or land animal products, as I think it was written, with 13,000 illnesses, and that's a significant contribution to illnesses in that particular country. I like to use, let's see if I can get this thing to move on a bit. Sorry, apologies. Right, sorry. Again, I like to use these data as well for illustrative purposes, although again they're a little old now. But I don't think the data has changed too much, to be honest. This is the baseline study that was done in Europe on Campylobacter in poultry. And the reason it's useful is because it's one of the few times, probably the only time, that a number of countries use the same protocol and sampling protocol and testing protocol to actually look at the prevalence of a particular pathogen in a particular commodity. So the data are directly comparable for once. And I think it shows really that with Campylobacter in poultry, it's a particular issue in Europe and probably throughout the world, to be honest, looking at the data. Campylobacter rates and prevalence range from 4% up to 88%. You'll notice that the Scandinavian countries were a lot lower than a lot of the other countries, but there you'll see in the United Kingdom 75%, Ireland 83%. That's practically near as damn it, the whole every poultry flock being contaminated at some point with Campylobacter. And therefore it's not entirely surprising, I think, even that we see that Campylobacteriosis in Europe accounts for the greatest number of illnesses. And the latest report on zoonosis is 2019 for Europe, and that highlights 220,682 illnesses associated with Campylobacter, which is about 2.5 times higher than its nearest rival, which is Salmonella. And bearing in mind that an earlier report from EFSA attributed 80% of cases of Campylobacteriosis in the EU to poultry. So there's no doubt that poultry products are a risk when it comes to Campylobacteriosis. If we look at a similar baseline data again on pigs, and again, I don't believe these data have changed too much over the years in terms of prevalence numbers. We're looking at an EU average of 10% of pigs at slaughter were contaminated with Salmonella, and that rose to 30% in some member states. Salmonella, according to the 2019 report on zoonosis for Europe, accounted for 87,923 illnesses. And obviously Salmonella from pork plays a big part in this, as does Salmonella in eggs. A similar study at the time in breeding pigs showed similar ranges of contamination, which shows you the problem there is with vertical transmission of Salmonella through the pig production process. So hopefully now you'll understand that meat and meat products form a particular issue when it comes to foodborne disease, and I'll take you now through the ICMSF recommendations for sampling and testing on these commodities. And to emphasize, as all speakers have emphasized so far, that these are recommendations, they're not statutory standards, but nevertheless, where there aren't statutory standards, they're a great reference, and we use them in Ireland ourselves to recommend to industry what they should do in areas where there aren't European regulations. So the meat and meat products and the poultry products are covered off in 2 separate chapters, one in chapter 8 and one in chapter 9, and we'll go through those now. So my right slide coming up. So the meat and meat products is actually broken down to several subcategories, and there are tables of micro criteria for each of these. We're going to only have time really here to look at a couple of them, and I've picked out 2 of the more common categories that are out there: the raw comminuted meat product category and the cooked meat product category. And I'll take you through both of those separately. So when we talk about raw comminuted meats, first, it refers to products that are made of ground meat of various consistencies. It can be fairly granular, or it can be right down to fat and meat emulsions with very little meat particle muscle visible. It includes products containing extenders and fillers like wheat flour, as well as those containing spices, herbs and flavorings. And I've just included a couple of examples there from Ireland that fit into this category. You would have probably many different products in your own countries that would fit in this category as well. The main hazards that you can see are, as outlined in the book, are Salmonella, which is pretty applicable to all of these type of products, Campylobacter, and bearing in mind we'll talk about poultry later, so Campylobacter in this context is an issue, more of an issue in the pork products, and then Este, which we've talked about before, the sugar toxin E. coli, would be an issue for any products made of beef or lamb in particular. And in certain regions, depending on controls, you'll see that Yersinia may be an issue in some of the pork products, and we've seen a few outbreaks of those, particularly in the Scandinavian countries, in Europe more recently. And Trichinella may also be an issue, depending on how good the control program is in the country of origin of the products. So in the tables, part 1 covers the process in-process testing and shelf life. And if we look at the critical ingredients, well, the critical ingredients really are the meat ingredients themselves rather than the non-meat ingredients, because primarily this is where the pathogens come from. Certain regions can have specific testing requirements for those regions, but certainly in the ICMSF, we believe that testing for 0157 could be useful. When this book was produced, you probably now test for generally for STEC using a different methodology, but only if you're concerned about your supplier control. In-process testing is definitely not recommended unless you want to establish a baseline contamination picture for the process and trend analysis, and that can be useful for a lot of industries wanting to know what their general contamination levels are to look for deviations using statistical process control. And process environmental sampling, I think John was talking about this a lot, very useful to ensure to verify and validate the cleaning before startup in particular, and those can be microbial tests, or more likely these days indirect methods like ATP. Shelf life testing of the products really is only recommended for chill stable foods, and then only if a company finds it useful for new products or packaging changes. Generally, you wouldn't be doing shelf life testing for these products, because they're going to be cooked afterwards. Testing of frozen products really isn't necessary. I think the issue you're concerned about here is more about spoilage, and that might be why you would want to do shelf life testing of any kind. When we move on to end products and looking at what should be tested, the testing for the indicator organisms, I think, is always very useful. It's especially if you're trying to establish a baseline of how hygienic your process is, and to monitor that the hygiene of the process against those levels. In the book, it talks about typical levels being 10 to the 5 CFU per gram for general plate count ACC, and less than 10 to the 2 for generic E. coli. But you have to remember, I think, that this sort of levels change region to region or manufacturer to manufacturer, and therefore these are only guidelines. You have to really understand what's applicable in your region or in your factory, and that can be done by baseline testing. It's also notes in the book that indicator tests are not useful if they're taken at retail stage, and often you see that these criteria are taken out of, say, the book and used at retail, and that's not really useful because it doesn't directly relate to the hygiene of the manufacturer. For instance, at retail, you could be due to poor storage room temperatures and handling of the meat products. So you're never quite sure whether the hygiene problem is at the retail level or at the manufacturing level. So it's not always applicable to use these testing for that particular purpose. Some regions have legal hygiene criteria in this area. For example, the EU has mincemeat criteria for E. coli, general E. coli, and that standard is an N equals 5, C equals 2, M50, small m50 and large M500 standard. And it also has a standard for aerobic colony count of N equals 5, C equals 2, large M of 10 to the 5, small m to 10 to the 5 and large M of 10 to the 6. So you have to be careful. The ICMSF has these recommendations, but you have to be very cognizant of where you're sending your product, whether it's going to be into your national area or into another country, and to make sure that you're complying with the legal standards that are in that country. ICMSF does not recommend routine testing for salmonella for lot acceptance. It notes though cognizant of legal standards in the area as well. And again, for example, in the EU, there's a standard for salmonella in mincemeat and mincemeat preparations of N equals 5, C equals 0, and absence in 25 grams. If the product is to be eaten without cooking, or it gets a less stringent standard, absence in 10 grams if the product is intended to be eaten cooked. Okay. Testing for the end product for E. coli 0157 is recommended in the book due to the outbreak history and severity of the organism, and that's reflected in the stringency of the plan, which is a case 14, requiring 30 samples. But probably these days, as we say, since this book was published, things have changed. Este serotypes we seem to find new ones all the time, and now we know as well is that probably the genetics of the organism is probably more useful to us to know than the serotype. It's probably best to test for Este in general using the ISO 13136 method, which has been published since that book came out, using PCR to detect the VTX genes from the enrichment media prior to further characterization of genes and also isolation of the organism. It's worth, I think, people looking at the WHO, FAO, GEMRA expert consultation on STEC and the virulence genes, and what they mean, what combinations mean what. And also in Ireland, we have our own analysis of genes that we've found in our own clinical samples, because in our hospitals, all STEC is tested in the hospital by PCR, and then if there's a positive, they actually send the whole stool sample off to the reference lab where the testing gets carried out and the whole genome sequencing gets carried out. So we've got quite a good lot of data, which generally shows us a whole range of different types serogroups that are involved in STEC illness, and with a whole range of different virulence characteristics. So in Ireland, we tend to view any E. coli with a VTX gene as being a potential food safety risk because of this. And we also, to note, we have one of the highest rates of reported E. coli, STEC in Europe. Now, let's move on to some of the work we've done as well in these areas, just to highlight. We've did a particular study, an official control study, as we call them, on mincemeat and burgers. And it showed the presence of STEC as well. We found 12 STEC positive samples out of 983, so it's fairly low prevalence, but we did find them. And we also found one salmonella positive sample. Now, did this really make a lot of difference at the time? It didn't make too much difference when we did the sampling, because in Ireland, the habit of consumers is very much to cook their burgers completely. Undercooking food in Ireland at the time wasn't really something the consumer did. Now, unfortunately, that changed, and it became quite popular to serve rare burgers, particularly in so-called gourmet burger restaurants. We're not talking McDonald's here. And we started to see outbreaks of STEC caused by this. So in 2018, our scientific committee made recommendations on safe cooking of burgers, which is the purple report there. And we followed it up with a cooking fact sheet on the back of that report, which is the other sheet you can see on that slide. Both of those are available from the FSAI website, which is www.fsai.ie. And since we've issued those, and since we've been enforcing that in the food industry, we've not had an outbreak of STEC from burgers since. So that's quite nice to know, and hopefully that's the reason why. But when you look at the data here, you can see that a number of different types of STEC were found: 0149, 08, 0130, different combinations of ET genes. So it is it's a very difficult topic to deal with, and in Europe, when they tried to harmonize microbiological testing of Este, particularly in meat. There was about 2 years of arguments, and we didn't arrive at an agreement at the end of the day. And so still member states are free to interpret the legislation as they see fit when it comes to Este. Let's move on to cooked meat products, perishable and uncured products. The things we're talking about here, cooked sliced beef, pate, meat pies, cooked ham, for example. A longer list of pathogens here, the ones we've talked about before with the other products, community products, but here you've got other issues. You've got Listeria monocytogenes associated with all kinds of products, these type of products, prefringens, when you've got an uncured product that you might have problems cooling, Staph aureus, when you've got issues to do with post cooking handling and potential problems with storage conditions, and of course the Yersinia trachella we talked about before. On cooked meat product testing in the book, the critical ingredients, again, it's just the meat itself, and it's not really recommended to test them unless you have particular concerns on the supply. So it's probably more as part of a supply verification program, which would be in combination with audit, etc. And you probably do testing just to verify your findings of the audit. In process testing, it notes that monitoring of cooking time and temperature is really the critical thing in all of these things. This is the CCP that's critical, but it notes that sometimes post-cooking processes samples can be taken and tested for Listeria species. And in some regions, that's actually required by law. Processing environment, very important for Listeria species monitoring, where the products can support the growth of Listeria monocytogenes. Sometimes it's a study for Listeria species alone. Sometimes it's specifically for Listeria mono. We tend to recommend studying the environment for Listeria mono. And it's particularly important if there's no listericidal heat treatment post-packaging. It's recommended testing for indicators of hygiene before startup, and in Europe, regulations require environmental testing for L mono, specifically for manufacturers of products that pose a risk for Listeria. Shelf life is important. Validation of shelf life, particularly again with respect to Listeria monocytogenes of these products, because many of them are cooked products are chilled and distributed chilled, and that's when Listeria can grow. And many of them have much extended dates on them, greater than 5 days. So therefore, they generally have to be set as a shelf life. And in the EU, the manufacturer must satisfy the competent authority that the Listeria monocytogenes will not grow above 10 to the 2 CFU per gram in the product by the end of its shelf life, and the rules are specified in the regulation. And of course, that applies to any products that are not naturally unable to support the growth of Listeria. So those that have got less than 5 days shelf life, those with pH less than 4.4, or those with AWs less than 0.92. Excuse me. Then end product testing, ACC and E. coli as indicators is useful for process control and trend analysis again. And again, the same levels I talked about earlier, 10 to the 5 for ACC, 10 to the 2 for E. coli, are what we would consider typical of good manufacturing practice. But again, regionally, you need to know what those are around your areas and in your factories. And then at there's several plans for pathogens depending on the product type. The plan proposed for Salmonella is for ready-to-eat products where Salmonella will not grow during the shelf life. A less stringent plan may be appropriate if the product is cooked by the consumer, or a more stringent plan might be necessary if there's potential for temperature abuse during distribution, so that has to be borne in mind. The sampling plan for Listeria monocytogenes follows the ones adopted in Codex and is consistent with EU regulations as well. The plan for Staph aureus is only for products where there are concerns that the products have received temperature abuse. The plan for prefringens can be used where there are concerns over the speed of cooling of the uncured meat products, and sample units should always be taken from the center of the product where it's slowest to cool. pH and AW may also affect that decision as well, because prefringens has a minimum growth pH of 5 and an AW of 0.95, so it depends on the nature of the product as well whether that's an issue. If ready-to-eat cooked meat products conditions do not support the growth of listeria, we talked about those conditions before, then you can have a less stringent plan than the one that's here. And I also note that in the original publication of the book there was an error on this particular table, so what I've laid out here is the correct version. That also will be the version in the downloadable chapter. We have guidance on cook chill, for example, and this guidance is downloadable from our website. It has tables for chilling recommendations for different sizes of meat products, and that can be very helpful for food businesses. And so I'll talk about poultry products now in the remaining time, and I've only got time to really talk about raw poultry products. We know what these are. Salmonella and Campylobacter are the main pathogens that are involved here, as we discussed earlier. The chapter does have a start where it talks about some of the primary production issues, some of the issues to do with small and large farms and intensive and extensive production systems. But there's not a lot of details, not a lot of room in the book for detail in that. So I'd always recommend people consult the Codex guidelines on the control of Campylobacter and Salmonella in poultry. It's got far more detail there, as well as look at some things like the control programs of countries like Sweden, where they've been very successful in removing Salmonella from their poultry production. Testing, again, meat ingredients not really recommended for testing unless there's particular concern. In process testing is recommended if tests after chilling suggest control of the process may be lost. So again, the control is on the process and testing is only if there's an issue. Sampling at early stages may help determine where loss of control has occurred, so that's also useful. In-process samples may also be useful to establish a baseline for control at various stages, and E. coli, ACC, Salmonella could be used for those purposes of hygiene indicator. Processing environment, testing before the start of processing to verify hygiene, again, is very useful. And in shelf life, it's not really recommended unless you've got new products, and particularly products that have added ingredients, or where you've changed the packaging system, particularly if you've moved from a normal aerobic pack to a modified atmosphere pack. We have again issued guidelines which are downloadable from the website on shelf life, going through the processes that you follow for shelf life, explaining when you might use modeling or challenge testing. So that can be quite useful. It's just been updated at the moment. And this is an example of where things go wrong. And you can see here that we studied modified atmosphere packed chicken, 25 kilogram trays at catering level. And the red sample is where an Irish producer and was sampled from day 1. The other 2 came from outside of Ireland, was sampled from day 7 when they entered the country. And you can see that 2 producers labeled the shelf life correctly, where that's the dotted line vertically goes down and meets the arrow, which was their point of shelf life. But in one case, you'll see that the dotted line comes down at about day 11, but the shelf life that they had labeled was 16 days, and those particular products were fairly horrible at the end of the so-called declared shelf life. So it's very important to look at shelf life properly when you're looking at these products. In terms of testing for end products, ACC, Enterobacteriaceae E. coli, can use as indicators of quality. Again, similar levels that we've discussed before. Psychotrophic bacteria may continue to grow in raw poultry during storage. So again, test using these sort of numbers for retail level may not be appropriate. Routine lot acceptance testing is not recommended for Salmonella or Campylobacter, although tests for the organisms could be useful for outbreak investigations. But you have to, again, be aware that in some regions there are legal standards. So in EU, there's standards for Salmonella, Typhimurium and Enteritidis in poultry products, which is absence in 25 grams, 5 samples. And also some countries have Salmonella and Campylobacter hygiene criteria, which are used to reduce the numbers of these organisms on poultry products, and the EU is an example of that. I think Marcel might have talked about this yesterday, but we've got the criteria on Salmonella and Campylobacter for process hygiene criteria in the EU, and generally it works on a rolling average. So your 50 samples, you're taking 5 samples a week, moving window of 50, and your as you move on, your last one moves off and your first one disappears, which means that you're only allowed to have, for example, on the Campylobacter one at the moment, 15 of your samples are allowed to be above 1,000 in that moving window, and it will move down to 10 in 2025. So you can use pathogens for hygiene criterion, and the idea in the EU is it's impossible at the moment to get rid of Campylobacter off poultry. So what we're trying to do is to drive that down with an increasing stringency in hygiene criteria, and particularly drive down the number of batches which are contaminated at high level, 1,000 being the cutoff. In Ireland, with the commercial slaughter of poultry is well controlled, often under the permanent presence of veterinary officers, but we do have a rise in the wish for on-farm slaughter of small numbers of birds, and this may be applicable in your country as well. We recognise the local issues as well as the hygiene and welfare issues, and we put a guide together in 2011. Again, you can get that off the website. And we also issued recommendations for reduced Campylobacter in poultry in Ireland, following our baseline of, what was it, 83% or something prevalence. And we've had a concerted effort on that by a multidisciplinary group of competent authorities, retailers, poultry growers and processors. And we're fairly sure now that the levels have come down considerably, and we're waiting for the final data to be published this year to confirm that. So concluding remarks then. The ICMSF recommendations are a guideline, and note in the back of the book that there is the plan performance. You can adjust the criteria using the ICMSF performance calculator, which you can download off the ICMSF website. The legislative microbiological standards in national and international trade need to be applied, so don't get confused between what's recommended in ICMF and what is actually a legal standard. Appropriate risk management measures are necessary when microbial contamination issues are found, and the ICMSF sampling plan performance calculator is really a very useful tool that you should have access to. And I'll leave it there and hand back to the chairs, and thank you very much for your attention.
Thank you very much, Dr. Anderson, for your interesting presentation. Before we continue, I want to remind everyone that we will be answering questions at the end of the session in this question and answer time. The last speaker for the webinar today is Dr. Robert Buchanan. Thank you very much for being in this webinar again, Dr. Buchanan. Dr. Buchanan was ICMSF member from 1991 to 2011 and consultant since 2012. He's a professor emeritus of food safety at the University of Maryland in the United States, first director of the university's Center for Food Safety and Security Systems, has almost 50 years of experience teaching, conducting research in food safety, and working at the interface between science and public health policy. First in the academia, and then in government service in both USDA and FDA. He has extensive experience in predictive microbiology, quantitative microbial risk assessment, microbial physiology, mycotoxicology, and food safety systems. Dr. Buchanan's presentation today is an application of principles to combine foods. Dr. Buchanan, you can start now, and I remind you that you have 30 minutes for your presentation. Thank you very much.
Okay. Good morning, everyone. Glad to be back for a second day with you. And I'm going to close this, and hopefully you can hear me fine. Hopefully they were working outside my house and a little noisy earlier, but it looks like they've stopped. So what I'll be talking about today is the applications of microbiological criteria for product acceptance, focusing on a class called combined foods. And Let's see if I can get this to work. Yes. And so my goal in this is to talk about the challenges of combined foods, which often represent a major challenge to the food industry. And then particularly when you're trying to attempt to establish microbiological criteria in any of the different subcategories that we've talked about before. And so what I'm going to be doing on this one, because it's a little different from some of the ones more standard products groups that we talk about, I'm going to be focusing my talk on the types of information and planning that's needed in order to manufacture, distribute, and market such products, with an emphasis on the fact that very often with this group of products, you will have to develop your own microbiological criteria. And I might note here, this is an area that has grown in size and in the duration of which some of these products are on the marketplace. They include both numerous ready-to-cook and ready-to-eat foods that combine different food types, and often they represent different compartments within the food. And what gets into a problem area is they often vary in terms of modes of preventing amplification of microbial risk and food quality defects. And it's really hard to come up with a simple definition. So we're going to go through and sort of deduce some of what is needed in this area. This is just some examples of different combined foods that are routinely on the marketplace, where you're mixing different food types and in often different food technologies in order to produce the foods. And this will include everything where you have things like pot pies. These are pizza rolls, pizza, a chocolate eclair. This is a mixed seafood and vegetable salad. And just to give you a simple example where you have these, for example, it's a favorite thing to take yogurt and put fruit in it. Well, that in effect winds up setting up two different compartments, one that is controlled by low pH to prevent the growth of microorganisms that are undesirable, and the other one is something that is controlled by low water activity. And so if you take dried fruit, you put it into a yogurt, the fruit's going to become wet, and this is also not a sterile product usually, unless it's been treated ahead of time, and so you wind up having a source of yeast and molds for your product. We've also seen this, one of the product areas that people have tried to produce for a long time is processed semi-dried sausages, where they actually put in processed cheese in the middle of it. And what happens here is that you get a cheese that has a high water activity, but at low pH. And when you put it inside of a semi-dried sausage, it winds up raising the pH and the water activity at the interface. And this has been demonstrated to be, one of my colleagues back when I worked at USDA did a piece of work demonstrating that at the interface between those two products, you would actually get Staph aureus to grow when it normally wouldn't in the meat itself. So just to give you an idea of the case studies that of the problems that do arise, this is a case study of an outbreak that did take place in the United States in 2007. And this is while I was still working for FDA. And then subsequently, I did some work in conjunction with the company that actually had the problem post my employment by FDA. So this was a Salmonella enterica outbreak. It occurred in pot pies in the United States. It's a frozen entree, and it wound up, after they looked at it, it wound up being a multi-state outbreak where you had 401 cases involving 41 different states in the United States. And one of the key factors that they did determine was that most of the meals that were produced and then consumed were actually reheated using microwave ovens. So looking at this case, so that you have an idea of what one of them might involve, this was the salmonella was isolated from patients. It was isolated from unopened packages. Okay, the positive unopened packages had turkey meat, but they couldn't rule out other ingredients as a potential source of the contamination. And the analysis of the samples, when they sort of took the ones that were positive and analyzed them, they found that salmonella was in the filling, but not in the crust. And so you had two different compartments here. And when they started to look at it, the interesting thing here was the turkey that was used in this product was cooked. It received a full cook that should have eliminated any salmonella. But also mixed into this was raw, other than blanched frozen vegetables. It was raw frozen poultry paste that were heated prior to being dispensed, though the degree of heating was never clearly elucidated. And then you had raw flour pastry shell and top that was put on top of it before it was frozen. And I might note here, we're talking about a large-scale operation. This was a facility that was producing approximately 1 million pot pies per day, and they were going out the door that way. Okay, the source of contamination to this date remains unknown. And the company that it was involved and the FDA looked very carefully into this and never could come up with a definitive source. So what could you do to prevent this outbreak? Is there any role that microbiological testing has that would help? And I'm not going to answer this for you here, but one of the things I do note is that the company that was involved in this then devoted a huge amount of time surveying people's microwave ovens. And what they found was the efficiency of microwave ovens, particularly as they age, becomes greatly reduced. And that made them go back and think about their instructions. And so we're going to follow this through, and using this kind of thought process, talk about the kinds of microbiological criteria that you would use with a combined food. And so the question that you immediately get is there a reference that I could go to and look up the microbiological criteria that should be used with my combined food, the one that I'm designing and I'm trying to market? And the reality is it's highly unlikely. Okay, but you have the ability to go in and use scientific principles, many of them that are outlined in book 8 of ICMSF, to help you deduce what is the right tools for your product. And so that's what I'm going to be talking about in this process. And what you need to do is, if you want to sell a combined food, you really need to do planning before you ever make any of the product. You need to have a process that requires a detailed plan. You need to determine how the product is going to be marketed. Is it going to be ready to eat, or is it going to be ready to cook? Are you going to make the product shelf stable, or is it going to require something like refrigeration or frozen storage during the process? You got to look at it not only from your plant, but you need to look at it from your raw ingredients up through actually looking at and evaluating the distribution and marketing, and make a determination on whether you're going to be targeting a local market, a regional market, a national market, or an international market, because this complexity is going to introduce things that you may have to control. Some of the issues that are going to have to be looked at before you even make any of a prototype, you need to look at the stability of your supply chain. Do you get huge fluctuations, as you may have an ingredient that you have to get from different regions at different parts of the year? You have to look at the past history of successful commercialization of similar type products. And then, very importantly, you need to look at past problems associated with similar products. So, for example, using the one I just gave you, if I was trying to stick cheese inside a meat product, I'd be really hesitant, and I'd really want to spend some time looking at it. Okay, so what are the steps needed as you go through this process of trying to evaluate a new product and how you're going to make it and make sure that when you put it out, it is safe and has of high quality? Well, the first thing I would recommend as a ex-regulatory person is that you need to check the regulatory authorities concerning the legal requirements for producing the products. And this has been mentioned also by the other speakers. And I put an emphasis on the plural here, because you need to look at where you're going to be selling the product. Are you going to be selling it in one country? Are you going to be selling it in one state? Or are you going to be here in the United States, for example? Are you going to use different states? What are the regulatory authorities? How do they differ from state to state? And even in some instances, when you're dealing with it, you may have restrictions in local, in cities, or smaller government units. Okay, next step is, once you've got some idea of what you're going to be legally required to do, then you need to develop a design plan. And what you need to do is gather critical knowledge that you need in order to make the product and make sure that it's safe. So after you have your basic design, then what you need to do is assess the hazards and risk. And hazards and risk are two different things. And you need to be able to understand that not all hazards represent high levels of risk. On the other hand, some what would be moderate hazards might have increased risk if they're particularly pathogenic. Then once you've done this, now you're ready to start developing prototypes and evaluating the characteristics of how you produce it, how it has shelf life, what are the different aspects that you're now going to have to face. And you're going to need, once you've got the prototypes developed, you're going to use this to validate the processes and the procedures that you're using, including what you're going to do along the marketing chain. Because particularly if it's a sealed package type product, you're going to be responsible for it as it moves along the supply chain until the consumer gets to use it. So you're going to have established verification protocols so that you're confident that your product is being manufactured, distributed, marketed, and most importantly, consumed as you intended. And so this is an important thing that I'll come back to in a second. This is a slide I put in just before this today when I made this presentation. What you may also want to do if you're in work and you're starting to develop these products, you may want to consider using an approach called red teaming. And red teaming comes out of the military. It's used extensively in evaluating food fraud and food defense type issues. But what it basically is that you have a team of if not experts, people that are well familiar with the issues associated with food safety and food quality. And once you have your plan in place and you have your data that you have available, you bring them in and they look at it to see if they can poke holes in your plan. And it turns out to be very useful. And it's one that helps you not get blinders on to some of the risks that may be associated with it, or some of the potential issues that may arise as you actually try to commercialize a product. So I've also, as I indicated, you need to be able to measure the microbial risk in a combined food. So you're going to have data in order to do this. An assessment of microbial risk in combined foods are generally much more complex than it would be for a single food. And because you're dealing with different processes, you're using the different processes with different components within the food. You very often are adding things to the product, such as toppings or seasonings, after the primary process is already completed. So for example, if you're selling pizza, you're going to wind up putting things on the pizza that you probably are not going to cook at the same time as the base pizza. And so these are going to have to, how you're going to handle them and what controls you're going to put in place. You have, as I've already indicated, you may have to evaluate how the components impact each other. Do they change your systems of controls that are preventing the growth of the organism or preventing its reintroduction? If this is going to be a product that requires reheating by the consumer, you need to understand how the consumer uses the product and how the consumer potentially abuses the product. And this is something that is very tough to do, but you do have to have some kind of an evaluation that allows you to make some really, do you need to put in extra controls because you know that a certain proportion of your consumers are going to abuse the product. And this would be particularly important if it's a product such as a refrigerated product that requires you maintaining the product at a temperature, or it's one if it's cooking, it's a product to be cooked, do they follow instructions? Okay, so in this process now, you're gathering critical microbiological data. And your first decision you have to make is, what are the critical microorganisms associated with the various ingredients? What are the risks associated with those microorganisms? And what are the means by which you're controlling them within your product? Are there microorganisms in one compartment of the product that would, if now that part of the food becomes in contact with another compartment, now will allow undesirable organisms to thrive and grow? What are the means that you control the organisms within the food compartments? And as I indicated before, does the interface between those compartments negate the control measures you're using to control it? And then finally, you got to make some decisions, because as you've seen from the other speakers, trying to look for really low levels of pathogen are very difficult. And what you're more likely to be more effective is finding good microbial indicators that would be good surrogates for assessing the status of the product. So you saw in the two speakers before me that if you're looking at meat products, E. coli may be a really good standard. However, if you're dealing with fresh vegetables and using Enterobacteriaceae is not recommended. And there's a lot of other details about the microbiological data that you need to do this. There's no chance that I could go into all the details of this, but I'm sure that most of you are familiar with many of them. Okay, it's also interesting is determining how you're going to market the product itself. Okay, and so I used here as an example refrigerated product versus frozen product. Okay, and so with a refrigerated product, it has some real advantages. It typically gives a better impression of freshness. However, it has very limited shelf lives, and depending on how this is done, that shelf life can be even reduced more if you have the potential for temperature abuse. If you have a situation where people either have a refrigerator at the wrong temperature, or if they have a problem with leaving it out and not putting it in the refrigerator when they should have. Frozen products, for the most part, stop microbial growth. Okay, so this is really good idea. But you need to make sure that people understand how this is supposed to be handled. If it's a ready-to-eat product, it probably needs instructions on how it should be thawed properly, at what temperatures, how long can you leave it out before you need to start thinking about the fact that it may be spoiling or you may have pathogens growing. For ready-to-cook products, you need really clear cooking instructions. And you have to make a decision, can you count on the consumer to follow those instructions? So a classic example where this has come to light in a number is the use of frozen vegetables that are supposed to require cooking instructions, but in many cases are being used by simply taking the frozen vegetables and throwing them into a salad. The other thing that I like to refer to is if you're dealing with a frozen product and you're ready to have it cooked, and particularly if it's going into a microwave oven, think about teenage boys coming in from a day of high activity. And I've, having raised sons, I know for a fact that they don't always heat them up. And even if they're a little cold still on the inside, they'll get eaten. So these are things that you need to understand about your customers. Okay, little discussion about the impact of scale and what we've seen in some of these cases. The commercial production of combined foods is typically much more highly controlled compared to how the product is going to be handled by consumers. And a major portion of the root cause analyses that have been evaluating products where there have been failures or there have been outbreaks, et cetera, have basically often linked it to the consumer mishandling the product or contributed to the risk associated with it. However, it's important to note that when you're dealing with this, the potential food safety impact, if an error occurs in manufacture or distribution, is going to have a much greater impact because you're going to be affecting many more servings, and you're likely to then, be identified as a major cause, as a contributor to this. So again, the contamination typically will flow through the product, and it's where you're looking at a mistake up this end is going to have a much bigger impact in terms of number of cases than one down at this end. Okay, so I'm going to jump into this, and again, referring to the ICMSF. And in the chapter on combined foods, the ICMSF used testing of a topped or filled dough product as an example. They couldn't come up with a detail of a lot of the microbiological safety and quality issues, but they did that. And I just like to review that for briefly. And again, we'll go back to the tables that were in the book. And what they're here is what they're asking you for the manufacturer to make decisions in terms of identifying what degree of testing is appropriate. And what they have is a lot of determining whether you have high or low confidence. So when critical elements, these two looking at mycotoxin potential in the flour or sensitive ingredients with no subsequent kill step, they're really being very indicating that this is where you do this kind of testing. It's of low importance if you have high history and confidence in your suppliers, less so if that is the case, and you may have to go through, if you're not sure of your supplier, then you need to do more testing yourself. In process, this is an area where it's looked for looking at either microbiological criteria, or certainly collecting data on to verify the adequacy of the processing. And again, this is going to be dependent on the individual products and the processes, where along the process you're actually looking. In the processing environment, this is again, you're looking at, particularly if you're doing toppings such as this, where you're adding things after the major kill steps, this is considered a high area to keep up on. And the one that is particularly looked at here is the presence of salmonella in the environment. And this is, you can look at other indicator organisms, though that's not always the easiest thing to do. If you're looking at shelf life, again, this is one where, particularly if you're dealing with a refrigerated product, you're going to have to know what the shelf life of the product is, both in terms of quality and safety. And so what you're going to be looking for here is this is going to be particularly high if you when you examine the water, the pH, the atmospheric conditions. And I might note this wasn't in the original ICMSF. If you're dealing with a volatile solid like preservative, like a essential oil, These things dissipate after time, and do they still remain effective in the packaging you use, or do they evaporate out and you don't make it through the shelf life? Okay, for end product testing, again, it's most end product testing is not recommended during normal operations. However, if you consider a situation where you think there may be a potential hazard based on the hazard analysis or some aspect of verification of the status of your process, then you may have to go back and start initiating it. So they did put up two in this one. One is frozen, ready-to-eat dough products. And the organisms that they looked at here were Staph aureus, and then Listeria monocytogenes. And then likewise, hit further down, there's Salmonella. And then there's a second Listeria monocytogenes. And the difference between these two is this is in a food where does not support the growth of Listeria. And this one down here is in a food that does support the growth of Listeria. And that's, again, reflects the Codex standard, which has been adopted by the EU. And there's some aspects of this that have been adopted by the United States. The second product in terms of pathogens is going to be in frozen, ready-to-cook dough products with low acid or high AW fillings. And again, the two that are selected here are going to be Staph aureus and Salmonella. You'll note here, because the product is going to be cooked, it's probably not, as it is for most of the Codex standards, for Listeria monocytogenes, this is no longer included. So see, I'm running out of time, so this is appropriate to make a couple of concluding remarks. The food industry is one of those few professions where one can start with a good idea and actually develop it into a multi-million-dollar industry. It's a place that attracts entrepreneurs, some of them not with a lot of experience in making foods or some of the requirements for do so. So many of these fledgling businesses fail due to not anticipating the challenges, particularly with these complex foods, for consistently producing high quality, safe foods. And if I gave any recommendation to any new people that are trying to get into the food business, food entrepreneur, get help. The governments, there are a number of different programs that you can take advantage of. There's professional organizations that can help through this. And the internet is a great resource for coming up with good scientific information that allows you to produce these complex products that are a challenge for even professionals. And with that, I'd like to say thank you.
Thank you very much, Dr. Buchanan, for your excellent presentation. We now have time for some question and answers. Therefore, we want to invite Dr. Michelle Daniluk and Dr. Wayne Anderson to join us for the question and answer. We have many questions, so I will try to cover as many as we can. And I will start with one that goes for any of the three of you. What can we do to better control foodborne pathogens in this type of foods? Will genome sequencing methods and other emerging technologies actually help, or some of the detection technologies will overestimate the role of these pathogens as disease-causing problems?
Interesting question.
I'll take a first crack at it, because that really was what my talk was oriented to, is that you're going to get into a food business, you need to understand your product, your consumers, you need to know what your suppliers are doing, you need to know this, and you design the safety and quality of a food into your system, not correct it as you go along. And this requires a good scientific basis, and it requires you do some really effective planning. It's a management issue.
I think as well, to add to Bob as well, whole genome sequencing, what we're finding now is we're picking up a lot of diverse outbreaks that have probably been going on a long time, particularly say with listeria. There's the example of the frozen sweet corn in Europe, which are going on for many years. Whole genome sequences has allowed us to identify those, so we're getting a better idea of what commodities are actually causing illness as well, which is very useful when we're trying to consider whether microbial sampling is useful or not for a particular product. And as Bob has said through his presentation, I mean, you could apply Bob's principles to any product that we've talked about here today, to be honest. At the end of the day, if you know what what's causing the problems, then you can identify those hazards and put in the critical control points into your process to deal with them.
Yeah, I think too the part of the question around detection methods and our ability to detect lower pathogen populations through some of the new detection methods is interesting, because it also comes back to, especially when we're not talking about sampling food products, but sampling inputs, acceptable level of risk in some of our input agricultural inputs, especially in the produce industry where I talked about, but it holds true on during any primary production. So I think the whole genome sequence, like Wayne said, allows us to identify outbreaks and to deal with that underlying burden of disease where we have not known the source in the past.
And if I can jump in here and also make a little bit of a plug. In 2 weeks, IAFP is putting on its European seminar or symposium. And Dr. Zwitterling and I and Martin Weidman are going to be putting on a session on residual risk and this issue of whole genome sequencing, where you feed millions of servings out to people, is basically doing away with the use of microbiological criteria that are realistic in terms of number of samples that would need to be done. And so if any of you are planning to attend the European symposium, I invite you to come and listen to our talks.
Thank you very much for your answers. Now, I have a couple of questions for Dr. Danny Luke. I will put them together. So the first one is, can pathogens get to the edible portion of vegetables through the roots? And the second question is, why is Listeria monocytogenes not discussed as much in produce, excluding fresh cut produce?
Yeah, so that's a great question. And I actually have a slide in my presentation that I hid this morning and didn't present that speaks to that very first question about pathogens getting to the edible portion of the product from roots. And so there certainly is a fair amount of literature out there going back well over a decade that shows that under the perfect conditions in a laboratory or even in a growth chamber, you can get pathogen movement from roots of crop into fruit. Now, there's a lot of nuance around those experiments, right? So oftentimes they will not grow fruit or the plant to full maturity. So you see this in a lot of work where they sort of grow a seedling where there's maybe 1 or 2 or 5 leaves not grown to commercial maturity. So we don't know what would happen if the plant grew further. Or you see situations where the number of pathogens in the media that was applied to those roots to see if you could get the transfer into the fruit is very high, 10 to the 9, 10 to the 10, even at 10 to the 6. And these are pretty unrealistic conditions for what we see in the environment. So we have yet to see any outbreaks that I'm aware of where there was documented movement from the root into the fruit of the plant. And certainly, is it possible? Yes. Is it likely? No. And it's not been something we've seen. Now, that's a very different situation from what we can see in a post-harvest environment. So during washing of different products, and mangoes, oranges, tomatoes are one where there's a fair amount of published literature. If you put a very hot fruit, in this case, into very cold water, the vacuum effect will suck that pathogen and water from the cold water into the warm fruit. And we see this in tomatoes often before they get fresh cut. The tomatoes will go through a step called plumping, where they're purposefully put into cold water so that they get that water rushing in. And so that's where that sanitizer water, the sanitizer in the post-harvest water, becomes so important, so that if we do see internalization post-harvest, we do see that internalization post-harvest, we will be able to control it through sanitizer in the water. So, but the root to fruit stuff shown in the lab, it's not something we've seen happen involved in an outbreak or ever in product produced under what I would call a normal growing condition for it. The second question as to why we don't look at Listeria monocytogenes on whole produce items is a great question. And I will say that historically, the reason that we didn't is that we didn't have a history of outbreaks to indicate that it was a problem. And so, you know, if you look back into literature 10, 15, 20 years ago, there's mention of it, but it's never mentioned as something of a concern because there had never been a problem about it. I will say in the last decade, since the 2011 outbreak in cantaloupe, and then followed up by a couple of other whole produce commodity outbreaks and recalls, we are seeing a lot more attention paid to it, and it will be something that I think we see a lot more in the future. I don't know if Bob wants to follow up on that at all, but
yeah. Well, I would say that, you know, it's certainly been known with sprouted seeds.
Yes.
That it goes up to high numbers in sprouted seeds.
Yeah.
Just as part of the normal processing, you put a small low inoculum in and it grows very nicely.
And that's true of most of the bacterial pathogens. They grow very well in sprouts. Yeah.
Thank you very much for your answers. So I have a couple of probably 2 or 3 questions that are mainly to Dr. Anderson, but I know also Dr. Buchanan can jump in. So the first question will be, okay, give me a second because I got lost in the chat for a second. Here it is.
Easy to do.
Yeah. Does it make sense to analyze non-ready-to-eat meat products, for example, bacon, for Listeria monocytogenes?
Non-ready-to-eat bacon for Listeria. Generally, I would say not really. The product's going to be cooked by the consumer. It may even be cooked by the manufacturer in pack, hopefully. But ultimately, no, that wouldn't be something that we would generally recommend to be done. And in the EU legislation, for example, sort of testing for this sort of stuff is generally in ready-to-eat foods rather than in that kind of product. Bob, would you have any addition to that?
The only thing I would say there is that whenever you're dealing with Listeria, particularly in a processing environment where you're cooking the product ahead of time, and then you have to worry about recontamination.
Yeah, that's the only bit. Yeah.
You can buy bacon that's been pre-cooked, etc. But again, recontamination, or if you're cooking it in your home and you're not really good at home hygiene, again, you can recontaminate it.
Yep.
Thank you. And I found the other one. I'm sorry, I got lost in the questions that are coming in. So the question is, what bacteria does research suggest to use to estimate shelf life of vacuum-packed chicken meat?
Vacuum-packed chicken meat. That's very interesting. When we looked at that shelf life study of modified atmosphere or vacuum-packed product, we were generally looking at TVCs, some Pseudomonas aeruginosa, and some lactic acid bacteria in terms of the spoilage. And I think generally what you'll find is that those organisms will grow better. The lactic acid will grow if there's lots of oxygen. Depends on what they're packed in. But in vacuum pack, you're probably talking about the aeruginosa. So TVCs are probably sufficient to be able to look at those and check the shelf life of them. But certainly you'd also be concerned pathogenically, depending on the temperature and the type of product we're talking about cold grown botulinum if it's refrigerated, and there are sort of standards in various countries around the world for how long the shelf life can be kept for those sort of products. But generally, for shelf life, yeah, you're looking at spoilage organisms really.
Bob or Michelle, do you want to jump in?
Yeah, you know, the spoilage of chicken meat, of beef, etc., are well established. When you hit around 10 to the 7th per centimeter squared on the surface of the meat, you're going to get the beginnings of off odors due to the metabolism of amino acids. When it gets up to about 7.5, you have slime formation. And these are well documented, and it does no good for a manufacturer to put these products out with an exaggerated shelf life if they're a refrigerated product, because what they're going to do is lose customers when they hold them within that specified period, and people open up and they're slimy and they smell really bad. So this is in part, as long as it's not a pathogen, this is an issue of commercialization and bad practices in terms of marketing.
I think it's worth saying as well, Bob, what we've seen is over the last, I don't know, 10 or 15 years is bulk packing in modified atmosphere or vacuum, and then they get shipped out to caterers, and the caterers or the butchers or whatever would open those packs and then sell them, obviously now aerobically. And they tend to apply the same shelf life, funny enough. So if the original pack said there was 10 days, 12 days shelf life on it, they open the pack and they apply that to the aerobic product, and that is absolutely a no-no, because now we've got a totally different type of environment. Different types of bacteria will now outcompete, and we've shown quite a lot extensively that they will spoil within 2 to 3 days. I don't care how many days you had on that pack when you opened it. So these sort of errors can lead to really poor quality stuff getting into consumers shopping.
And I think that's why you see more and more of, for example, chicken breast. When they're sold in individual plastic pouches that you rip off one out of a string and use it as you need it.
Yeah, exactly. So it's a big one that I have seen fall. It's like countless, so many times it's fallen over, and I really am not surprised that people end up throwing away chicken from the fridge, which isn't good for food waste and the environment.
Thank you very much. We have another question regarding the use of emerging technologies and the principles and guidelines that we have discussed today. So what do you think about, or what is your opinion about the use of the principle and the guidance that we have provided with the emerging technologies? You mentioned a couple of them, Dr. Anderson and also Dr. Buchanan yesterday.
Yeah, I mean, I'll start off this. Bob will definitely come in on this one, and maybe Michelle as well, because we're seeing these applied across the food industry now. High pressure will probably be the most developed one, but we're increasingly seeing things like pulsed electric light and maybe some other types of processing. It's one of the issues we've had as well from an enforcement point of view, because many enforcement officers wouldn't be familiar with these technologies and wouldn't, they go into a factory, they see them used, and they're really not able to judge whether that's equivalent to a process, a thermal process, or whatever they'd be used to. We've produced guidance on this for industry. It's again on our website, that gives them a sort of a template to follow on how they might validate how that new technology is producing a safe food, the steps to go through, the kind of evidence they might need to generate. And a lot of it is very, very similar to what Bob was talking about in terms of the steps that you go through when you're producing a new product. At the end of the day, you have to validate that the new process is safe, and verify it on a day-to-day basis that you're able to operate it under a food safety management system.
I would absolutely agree. I do caution people when they're using new technologies that make sure that you understand what the limits of the technologies are most of the new technologies are good for pasteurization.
Yeah.
They are not good for sterilization, even commercial sterilization. And then what's also difficult is that for a number of the technologies, actually having reproducible models of treatment times and conditions and are not always readily available. And so you have to make sure that you can actually understand when you give certain amount of a treatment, you're going to get certain amount of kill, and it's always the same whether you change the pH or whatever of the system.
And I think that's the key, is to actually understand what's going on and to build that into the critical control points, the critical limits, and ensure that you can do that on a day-to-day basis. And it's quite a complicated process, and you need people who know what they're talking about to help you.
Yeah, and you need to not trust data on a different product than your product too, right? The data has to be very true for your product and your process and your flow. And so I think that for me is something I often see is relying on data from something else to do it. But I certainly am encouraging of the new technologies evolving and getting those data sets to be used. Yeah.
Absolutely.
Yeah, no, I totally agree with that, Michelle. And we see that in shelf life, funny enough, the number of manufacturers who just look at the competitor's product and apply the same shelf life without doing any testing whatsoever is just hilarious. That's not really hilarious, frankly, but it's pretty manky, really. But yeah, it's not a good practice.
Okay, we have a final question, and I think this one can go to the three of you. So many of the emerging pathogens seem still associated with meat and meat products. As we see a shift in production and consumption of plant-based products, is there any watch-outs for new microhazard in such foods?
Ooh, well, I can put my feet up and Michelle can take center stage.
You want me to go first? Yeah, that's a fantastic question. So I think the question plant-based protein is so dependent upon what the source of the protein is and the conditions to get it. And then I think the processing around where how the new product is developed, I think is for me, I don't know if it's new pathogens or just old pathogens in new products or new locations where I would say there certainly is some interest. In terms of emerging pathogens in agricultural commodities and raw agricultural commodities like fresh fruits and vegetables, the one that I have my eye on right now are some of the parasitic, the parasites and parasitic pathogens. I think that as our detection methods get better, we're going to get better at finding them in the environments. And again, I don't know what that means in terms of risk. So yeah, I would look at some of the parasitic pathogens to emerge. And then I think, tying back to the earlier question about whole genome sequencing and Wayne's comment about the Listeria monocytogenes linked into the frozen corn, I think we're going to see a lot of food products that have never been associated with a pathogen emerging as a source of part of the burden of foodborne illness in the past. So I'll turn it over to Bob and Wayne.
Yeah, what I would say here, and I'm just going to use the plant-based hamburgers or whatever they're called now. Until if someone comes out and makes a case that this is a safer product because it's made from plant material, I would be very hesitant to believe what they say unless I saw the data. And until such time, if anybody did recommend to me how well done they should cook their burger, whether it's plant-based or it's beef-based, I'd say get it up to 165 degrees and follow the recommendations for the product that it's replacing.
Yeah, I think that's a safe piece of advice, Bob. I mean, at the end of the day, you've seen from Michelle all the data that links pathogens into plant products. The only thing you can say is very many of the plant-based products that are being produced at the moment in the current trend for vegetable protein are quite what you might call highly processed. They've got a lot of preservatives, salt, etc., added to them, might be even low AW or whatever, so they're actually quite a processed product, even though they're called a plant product. And people think they're a lot healthier for them, and maybe they are, but in reality, I think some studies have demonstrated that they're not as healthy as people think either. So in terms of the bacteria on them, I think whilst we have animal production and plant production coexisting on the planet, we can't assume that plant products are going to be free of animal pathogens. Maybe in I don't know, 100 years, 200 years time, Bob, when we're no longer farming animals and everyone's eating plants, we might not have the same sort of issue, but at the moment we do.
Well, we have the other thing that I would make a point here. If you have someone busy producing a plant-based burger, again, as an example, you want to make sure that the company is also in the same facility not producing beef burgers, because you're going to wind up with the same pathogen, and particularly if they're sharing the same packing line. Yep. So this is a new area, and I don't think that necessarily the regulatory aspect of it, and just from the fact that here in the United States, one is theoretically should be regulated by FDA and the other should be by USDA, and you need a harmonization of approaches to achieve the same level of control.
It becomes even more important to use your thermometer when you're checking your cooking.
Yeah,
and I think
the visual clues are going to be much different.
I think we didn't discuss even some of the unique new animal proteins, like insect-based proteins that the EU report just came out on. So I think and I don't think ICMSF has any recommendations related to insect-based proteins.
Not at the moment.
Just too new. So a lot of fun things that are emerging with new food technologies.
Yeah,
well, having consumed them in other places of the world where it's part of the normal diet, I just make sure they've been really well deep fried.
Yeah, I see there's quite a few reports on safety of those products out of the Netherlands, which are quite useful reference sources as well, if people are interested.
Okay, thank you very much. On behalf of the Latin American Subcommission of the ICMSF, I thank the speakers for the presentations and participation in the discussion session today, and for the great contribution for the success of today's webinar. We hope that participants have enjoyed it as well.
Very definitely. Thank you.
Thanks everyone.
Thank you.
Before ending the second day of the webinar, we would like to acknowledge our sponsors, 3M, Merck, Institute of Food Technology, and FORC, without whom it would not be possible to offer this free webinar to so many people, not only from Latin American countries, but all over the world. Today we have near to 220 people in the webinar. The recording will be made available after editing. Tomorrow we will inform more details, and thank you for your understanding. Don't forget that tomorrow is our last date. We will discuss myths and effects on transmission of COVID-19 by food. We wait, and thank you very much for all people, and goodbye.
Each time there is a contamination in food or beverages, the public is made aware. What they don't see is you, mitigating risks every day, taking difficult decisions and making our food as safe as possible. Because you take your job as seriously as we do. With over 350 years experience in highly regulated industries, we understand the importance of reliability and efficiency in your lab. So be it to verify existing methods, stay on top of changing regulations, or to adopt the newest technologies. You can find it all on sigmaaldrich.com. Tailored products for each step of your workflow available on our website. We have products that are suitable for microbial and analytical needs in the crucial step of sample preparation. We have solutions for the most routine sample analysis to advanced genetic detection, such as the Assurance GDS for rapid pathogen detection, often used to test for E. coli in beef. And we support you with a complete set of services and specialists. Our experts are here to improve your day-to-day work with 4 dedicated portfolio brands: Millipore, Sapelco, Sigma Aldrich, and MilliQ. All these products can easily be ordered on our website so that you can focus on making sure that every sip, every bite is safe because it's been tested by you.